Twitchies. Okay. The repo's called twitchcore. It's on GitHub. This is something I've been wanting to do for a while. I've never written a processor before. So that's what we're doing today. This is the spec. Downloaded it off the internet. The RISC-V instruction set manual. What's up? Yo. All right. So now we'll wait till we'll wait for the announcements until some more people get in here. We are drinking a Red Bull today. And we're going to implement RISC-V. Now I was debating, should I go right for Verilog or should we start in Python? And you guys tell me, should we start with a Python implementation or should we go straight for Verilog? Verilog, Python, Verilog, Python. All right. I see more Pythons than Verilogs. So if you've been paying attention in the TinyGrad repo, in TinyGrad now I have an extension. I have some instructions which are an extension to RISC-V. Oh, by the way, if someone wants to fix these things are failing because install OpenCL is failing. So if someone wants to submit a pull request to fix the test on TinyGrad, I would appreciate you. If we go into extra RISC, these are some extension instructions basically based around this internal map mul core. And yeah, if you implement these, you can implement almost all. I haven't done the reduce instructions yet, but almost all of an efficient net using TinyGrad. So I just want to get a feel for processors and you know what things like pipelining actually look like. I don't really know. All right, so how many viewers we got? I got 233 viewers. All right, well, we'll start with a few. We'll start with a few announcements. Reddit, comma.ai. So you guys, we'll talk a little about. Well, it's not really about comma. It's about Nabil Day. It's kind of Nabil Day. We doubled the price. We doubled the price of the comma 2 in honor of Nabil. And then you get like these people. It's a kind of joke in that's not funny at all. In fact, it's a slap in the face to the customers. He needs to clear this with someone who's not on the spectrum before posting. Yeah, these childish antics are what keep the big players from taking Hotz seriously. Dude's brilliant on a terminal, but he should really leave marketing, PR, and comedy to the experts. Now, let me explain. What he's really saying is that he feels more comfortable with the professional managerial class running things. Right now, from my perspective, the professional managerial class sucks dick. And there's no point in having, your own company if you're just going to, do what the professional managerial class wants. Then all you are is somebody's bitch. I wrote a blog post where I explained the the lyrics to it was not called the Civil War because people were civil. And I called the blog post a circulation of the elites. If you think of the elites as the professional managerial class, you know, the kind of people who you would clear this with. Yeah, well, I think those people suck dick. So yeah, if you don't like it, I mean, you know, you can go like yeah, like go yeah. So professional managerial class. Oh yes, please use your buzzwords that are absolutely meaningless. I really went on a tear on LinkedIn yesterday. You know, it's people. It's gonna be over. It's gonna be over. So yeah, the professional managerial class sucks dick. Just remember, every time you see them, whenever there's a simple concept that's being explained incomprehensibly, or whenever you know, you hear comments like this about, you know, like how the experts, anyone who's a quote-unquote expert is a member of the professional managerial class. You know, I find that interesting. Like, you'll see some like right-wing stuff where it's like, don't trust experts, right? And the problem isn't experts. Everybody loves experts. Everybody loves people who actually know what they're talking about, right? What they actually, I think, mean is don't trust members of the professional managerial class, and this is absolutely true. There's a caste system in America. America, of course, likes to deny it. This upper caste has a whole set of interesting tricks that they use to kind of stop people from seeing their power. But it is power, and they do have power, and they suck dick. So that's the rant about that. What was the other thing? Oh yes, I have a new song out on my SoundCloud. It's a cover. And we'll listen to this while we get started here. I come over, she's sitting in my driveway. I didn't want her this time, I didn't want this my way. I wanted yours instead, whatever makes you happy. I'll fucking go to bed. I can hear your friends laughing, and they are laughing at me. Don't lie to me, I know it. They fucking wanna break me. The way their eyes look show it, and I will probably let them. They will get what they want, and I will probably help them. They will get what they want. He's lying on my bed, I guess he needs to sleep. I think you lost all of my secrets I couldn't speak. And I keep writing poems I'll never keep. And she keeps knocking on my door when all I wanna do is sleep. She hasn't slept for days, I fucking wonder why. She hasn't slept around, she left to go get high. She says she hates her friends, cause they call her all night. She's turning off her phone, she's going out tonight. The notches of your spine are looking sharp tonight, and you think that I won't notice if you mouth the words this time. But I won't pull my punches, I'll use my words to knock your teeth out one by one. And I'll keep count of all of them, oh, I'll count all of them. Hold your tears back just for another minute. She says she wants her gift back, she said she thought I'd get it. You say you're friends, well what's a friend without a secret you'll pretend doesn't matter? But I have friends, oh I have friends, and they all matter, and they all care about me. She don't know what that's like, she says they wanna fight me. I won't come home tonight, but now the tables turn, because I won't fight back. I will just let them hurt me until the world goes black. I think I know what's coming, and I just don't care. I wanna break my glasses, I wanna dye my hair, so that I can go home and they won't recognize me, and they can see him clearly, and I won't see her eyes mean. The notches of your spine are looking sharp tonight, and you think that I won't notice if you mouth the words this time. But I won't pull my punches, I'll use my words to knock your teeth out one by one. And I'll keep count of all of them, oh I'll count all of them. Yeah, so that's that. Hold your tears back just for another minute. She said she wants to get back. She said, well, come and get it. Thank you for the hype train, boys. All right, so say ends equals that. All right, so we got a pipeline. Processors have pipelines. I dropped computer architecture when we had to make these stupid Excel spreadsheets, so I never actually wrote a access right back. So this is fetching the instruction. So the other thing that we want is we're going to want tests. And I saw some good tests here. So let's just call them tests. God. Put some J in that bitch. Okay. And then here we'll we are building an RV32i. No. Where does this go? Is RV32UI? Let's see, it just tells me here, doesn't it? UI is user level. Okay, users. Users, eh? We got users. Oh, God. Okay. Oh, it's a fucking elf. Alright, should we load the elves in Python? I think we'll load the elves in Python. What is it? Glob.glob. We got a glob. RISC-V tests. And we'll reuse these same tests for the Verilog implementation. We don't want the dumps. Wait, what's in here? Oh. How do I filter out the dumps with glob? Notches of your spine are looking sharp tonight, and you think that I won't notice if you mouth the words this time. Let's see what the glob syntax is. Alright, we're done with the Red Bull for now. Drink a bottle of Red Bull. Let's get some water. This stream is brought to you by water. Alright, so I think we can do... Nah, you know what? You know what's easy? If x dot ends with dump, continue. Alright, lazy bullshit. Alright, cool. So these are all tests. I think we actually want that on there too. Great, and these are elf files, so Python elf, yeah, PyElf tools. Do we have PyElf tools? How to use it? Please consult the user's guide. It's a useless user's guide. Alright, we got elfs. We don't know ITER sections. Oh, God. I just want like the code, you know? Alright, here's the test for OR. Or media, let's say. Alright. Jumps to handle reset. Loads a lot of zeros and some registers. Sorry, I'll move me. RISC architecture is going to change everything, boys. All right, let's say, can I do get section by name dot text? Seek of closed file. Oh, that sucks. Okay, memory submit text is text, while step, yes. Make this return false. Sure does not support item assignment, eh? We want some bytes. String argument without encoding, eh? Bytes does not support item assignment. What supports fucking item assignment? Your item assignment. Unpack requires a buffer of 4 bytes. Is that not 4 bytes? Oh, probably because I didn't set. Okay. We have to. The start address is reg file sub PC equals this. Assert adder greater than or equal to 0 and adder less than length memory. How come this one doesn't have a text? What's a P? Looks like text to me. How come this one has one and this one doesn't? Text.init. Oh, this has a text and a text.init. Oh, wow. Well, that's fancy. All right, so really what we want is text.init. And then it might call into things that we don't have because we didn't load .text. Oh, this is frustrating. Okay, you know what? Let's just say w dat adder adder minus equals 100 blah 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 blah. Memory equals memory sub adder plus dat plus memory sub adder plus dat. Okay, there we go. Take that. Yeah, fuckers. All right. W S. Okay, so now we can say something like s.adder s. Null section has no address. Okay. I can't believe I have to write a fucking elf loader, you know? Name, stream, struct, data. Those right. Do I want sections or segments? I think I want segments. Segment object has no name. Does it have an address? Which one of these has an address? Elf, segment, section. I always forget this stuff. One of these is actually loads. Segment tells the operating system where it should be loaded into virtual memory. Okay. Here we go. So now we just do ws s.data s header p adder. Should be right. What? This should be okay. Okay, we need more than 4K memory. All right, fine. Give it 64K memory. Wow, that's a lot of memory. All right, cool. Great, now my shit loads. We wrote an elf loader. Wow, we have to write an elf loader. I didn't think we'd have to write a stupid elf loader. The good news is we'll be able to reuse this crap for the the Verilog edition. All right, cool. just write a quick, write something quick. Dump for I in range 32. What does RISC name them? X. Okay. Let's. A space here. Actually, what I really want is that X to like. God, how do I do that? 3S XDI. That'll work. Cool. I'm gonna need a space before PC. All right, great. Now we're doing a state dump. 2 space before PC. Great. High quality. Of course, it's doing nothing right now because we're only taking one step because we're returning false. If we return true, it's probably going to loop forever. Yeah, it loops forever. All right, cool. What's the first test? It's add. Oh, that's a nice one. Okay. So. We're going to have to start decoding instructions. Let's just bring up what we're actually doing here. So it's add. All right, so the first thing it does is a jump. So we're going to have to write jump. It's 4 types of instructions. There's R, I, S, and C. Oh no, R, I, S, and U. Cool. Well, that's great. How do I know which type it is? Just write decoders for each one of them. There are further 2 variants. We got to do the BJ instructions, I say. Is the J-type instruction. You can't just make up new types of instructions. There's only R, I, S, and U. How do you make up J's? Okay. Well, it does seem like the opcode is universal. Yes. The last 6 bits are always the opcode. I mean, okay, so this is little endian. Let's just remind people that it's little endian by putting a little endian there. All right. I'll go back to returning false because we didn't process that instruction. All right, cool. So this is the instruction. Wait, so is the opcode... Where's a table of opcodes? Control transfer instruction. Okay, so what instruction is this supposed to be? It's a J. Opcode should be 7. But I don't see a 7. Oh, is that big endian? Did I do it backwards? Is this one little endian? That one's little endian. Well, actually, if I just delete that, we should get... Oh, yeah, don't get it twisted, boys. I got it twisted. Alright, cool. So the actual opcode is then... Okay, so they want 6, so we can say opcode equals ins, and if we want 6 bytes, it's sorry, 6 bits, it's that. Is that right? Let's not think that's right. All right, so 47. That's not 6 bits. Because that's not 6 bits, it's 7 bits. And for 7 bits, we put a 7 there. All right, 7F, all right, 111. Maybe that's not what this 7 means. That's just the width. Oh, okay. All right, there's got to be like tables. Where's miscmem from? Instruction set listing. Oh, okay, here we go. Why do they put it in shitty binary? Can't they use normal people numbers? RVG. Use the abbreviation G for the IMF Dad Zixer Zifensi. Okay, that's great. Maybe I picked a stupid one. Let's do a more common one, like XORI. Hint instructions. Opim? Why is this a G? I don't understand that. Oh, okay. Maybe that's not a general purpose. Maybe it's called an opim. Where's the list of the opcodes? You guys find that in this manual? You see what I'm looking for, right? Good, there's an index. Let's go to the index. Encodings, load store, opim, Louis, hint. Doesn't it tell me which is which? It's at the end of the table. Where? Like this? Oh, here we go. RV32I base instruction set. Okay. If opcode equals okay, what should I do? Make a enum. I did this in TinyGrad. Enum. Enum import enum class ops enum with like Louis equals boy piece Jal. But this isn't really the names of those things. Because those are all that. Do they have like a better name? Do you know what I mean? Jaller. Like, notice how all these are the same. Add upper immediate to PC. Oh, that's great. Fence. No, they have to have names for these things, though. Yeah, like this one's a branch opcode. That's what I mean, like it's not here. Well, either way, fine. We'll just figure it out. All right, this is a branch opcode because we have multiple of them. This is like a load opcode. We'll keep these at the bottom ones so I don't actually know the names of. And this is like a shift opcode. And this is like an ALU opcode. Yeah, it's different. This is like an ALUI opcode. This is like an ALUR opcode. They have to have better names for these things. Fence is real. And then we have, this is like an E opcode. That seems like all of them. Let's figure out the actual name of the E opcode. What's called a system opcode. See, like, who would know that? Stupid. Stupid. All right, so I have a Srali. Let's figure out what a Srali. It's an IM opcode. So I called it a shift, but it's actually an IM opcode. Not that trolley. Op-im 32. Okay, what about a slit U opcode? What's a slit U opcode? Oh, it's just called an op. What did I call it? I called it an ALUR. So this is just called an op. So this is an IM opcode. This is a, what is this opcode called? Okay. Oh, the Srali is the same as those. Oh no, okay, no, we have shift opcodes. Oh, that's not right, okay. God, this is stupid. All right, IM opcode, op opcode. That makes sense that that's an IM opcode. No. The IM opcode's actually this one. And then this one's still like shift or something. In the kitchen, cooking food. Louis. These are also IM opcodes? No, that's a Srali. What if it's not a Srali? All right, let's just, we can figure it out, I think, from here now. All right, so we have Louis and IPCs. We have IMs. We have opcodes. Who named these? We have JAL and JALR opcodes. Oh, branch opcodes. We have those. Good. Load opcode. We don't have a store opcode. We do. Oh, I named load correctly. All right, we need to figure out what the store opcode. Oh, that might. Those will not be shifts. That might be store. Oh, that makes more sense. Okay, good. I think we named all the opcodes. Okay. 1, 2, 3, 4, 5. Let's kind of break these down. Is it actually called a fence opcode, or is that a system opcode too? Z-Fancy. Oh, Z-Fancy. Oh, great. Who named this crap? Now, I'm complaining, but this is actually like one of the cleanest one of these I've ever read. The ARM one is much more of a mess. This is why I've heard actually such good things about RISC. Okay. So these are the opcodes we're going to have to implement. This goes down there with the bullshit ones. Those are the same. What's a Louis? It's a load upper immediate. Load upper immediate. Load upper immediate. Put that with the loads and stores. Someone said what AUI PC stands for. It's add upper immediate to PC. It kind of goes in there with the branch instructions, right? Because anything that modifies PC goes there. Jals and Jallers, these are the kind of ALU ops, and fence and system are stupid things we probably don't actually have to implement. All right, great. Of course, there's no such thing as a switch statement in Python. So the first one we're gonna have to, how do I do an enum lookup? See what I'm saying? Python enum. Okay, we just can do ops. That should work. Loving enums, bro. Twitchcore CPU. All right, look at the opcode. It's a JAL. Oh, we just gotta make JALs work. Okay, if opcode equals ops.jal. Okay, what do we do for JAL? Let's go figure it out. You know what I'm excited? Is it here yet? No. Oh yeah, some guy sent me an email this morning. Time-sensitive AI Forbes feature opportunity from this guy who runs this PR firm. And I replied with, lol, the media is a bunch of whores. The professional managerial class never would have approved that, but it's true. Hating on the media is just like, that's just like, no, what I'm excited about though is my I bought a little keyboard, like a piano keyboard. Oh, I had another Forbes reporter like send me some racist shit, and I was like, bro, this is racist. Like, you know, I would expect this from like BuzzFeed or Business Insider, but I thought Forbes had standards. And then like he defended Forbes, and it was kind of sad. Like, this is just racist shit, man. Fuck racism. All right, the JAL instruction has now moved to the U-type format. All right. U-type. Oh, U-type. Okay. Let's write a get bits function, and let's call it Jibby in honor of Jibby. Say ins se, and like I can change this to Jibby ins 60, and we want to do like ins shift e, or with and with one shift s minus e minus 1. Is that right, boys? Did I do it right? I don't know. Let's see if we still get JAL. Oh, we messed it up. All right. One shift left. Oh, I think a +1 here is right. Oh, let's just try it. Cool, it works. Yeah, JAL. You guys know Jibby? In honor of Jibby ASMR. Everyone's a little bit racist sometimes. You guys remember having your queue? So we want to do Gibby ins 3112. Say im equals that. We'll say rd equals 11.7. How do I run a JAL? We got rid of the J immediates. Here we go. Offset. Why do they make it so complicated looking? RD equals X0. So we'll have assert RD equals X equals 0. And then we want to say shift 1. Make that a hex. All right. Wow, we're really jumping to 1800? That's a pretty long jump. No, we're jumping to C. Oh, we did it wrong. Oh my God, look at how you decode this. Oh, this is stupid. Why'd they do it like this? Look at how much harder my life's gonna be because of this. Oh, Gibby ins. Look, it's like jumping all over the place. Okay, offset equals Gibby ins 3021, shift 1, or with, okay, right over here we have im20, which is this. Why do they do this? Shift 20, or with that, or with Gibby ins 20, 22, shift 11. Oh, I don't know what the binding precedence of shift is. 1912, and we want to shift this 12. That just happened to line up. Offset. Right, make sure you get like C. All right, cool. C is a good offset. The address of the instruction following the jump JAL stores the address of the instruction following the jump into register RD. Oh, RD doesn't have to be 0. It's just, oh, I get it. All right, so that actually doesn't have to be 0. All right, well, I think here, we want to do this in like write back or something, but I really think we can just do reg file PC plus equals offset, and that's going to work, and then return true. All right, that should run JALs. Hex reg file PC. All right. Now we just got to do an ops im. Instead of doing that, let's do this, and that. Get rid of those hexes. Yeah, buddy. All right, cool. Look, this looks professional. That looks we went professional. About to be professional. The rules of this channel is like, if you piss off a moderator, you're probably pissing me off. And, you know, I like, don't piss people off, you know? Okay, else if opcode equals im. All right, we got to get ims to work. Op im. Oh, it's an op im. It's not just an im. Should we call it an op im, or should we just call it an im? What? Oh. Sham empty, eh? Srally. Okay. We'll grab the RD. Grab RS1. This looks universal. This is a J-type instruction. And op-im is a doesn't match any of these. Oh no, maybe it's this one. It's an I-type instruction. I-type instruction. Good. We got RS1. We gotta change this. It's not right. Func3 equals Gibby. And then we have im. All right, we're gonna have to figure out the func3s. Gibby. I could put Gibby inside step, and then we wouldn't need to pass ins all the time. That's pretty cool. I think we should do that. This should work, right? No! Oh, because we have to Gibby up here. Too much ins going to Gibby. Good. Add I. Okay. Those are the different funcs. Wow, add and sub are the same, you just set this differently. Alright, well, this should be pretty easy to write. Class, what do we call it? Func, enum, add I equals 3 zeros, split I equals that, split I u, XOR I equals that, or I equals that, and I equals that, sly equals. You guys see where I'm getting this from? Srally. That we'll say also srally. Shry. Sry. Oh. This is. Wait, how do I distinguish? Oh, it has a different. I see. Also add sub. Can't do subby? No, I can't do subby. Soul. Dude, this is actually real fun. We should get rid of the eyes, I guess. There's probably like a better way to name these things. Like, is there a table of all the func3s somewhere? No. Oh, but there was more about fence up there. Are they called fence instructions? No, it's a MISC instruction. Can I bookmark pages in here? Formal memory extending. Oh, here we go. Okay, got it. Let's just order these by numbers. There has to be only well, we have 3 bits, so yeah, that's it. Also add sub. What else is this? Sly. I think, is that only Sly? Looks like it's only Sly. What else is this? No, no, don't do that. I wanted to just light up all the things. Useless. Okay. Also slit. Also slit U. Also XOR. Also OR. Also AND. So we're just gonna get rid of these I's unless also sir, and that one actually is only SSLI. So that can stay. We'll get rid of the I's from those, get rid of the I from that. Alright, cool. And we'll call these funct3. Should I put them all in? Like, I don't know what enum is going to do if I do this. Just try it for one. Print funct3, funct3. Actually, we'll do one better here. Funct3. Loving the enums, bro. I love Python. All right, so it's a funct3 add, which is great. What if I also put sub in here? What happens? Oh, it's just add. Okay, that's good. They don't actually have to be unique. You're like, George, you could probably just download this from somewhere, but then you miss the point, because we are learning about how microprocessors work. Okay, this is an im, so we'll say if funct3 equals add-I, here, even though it's not all that, it should still work. It does. So we're implementing add-I. We're just gonna say, I mean, really we should do this in the write back, but you know what I'm saying? Reg file sub rd equals reg file sub rs1 plus in. Right. We just implemented add. Else raise exception. Write R do funct3. Return true. We don't actually want to return true because we want to go to the next instruction. Reg file. We'll have to refactor this in a minute, but for everything except for jump instructions. All right, great. Okay. Well, those are not actually adds, though. Oh, I guess we're adding from register 0. Let's put a print here. Yeah, that seems cool. All right, so that's actually a lie. And now we just got to do an all PC. Add upper immediate to PC. T0? What does this all PC instruction do? Add upper immediate to PC is used to build. Oh, I get it. So it actually stores it in that register. Yeah, okay, cool. So that's a dest thing. So what kind of instruction is that? It's an all PC. Else write, we'll say write func3. And here we'll say write opcode, and then otherwise we'll don't have execute and stuff. All right, great. Expected an indented block, yeah, because we didn't write all PC. All right, all PC uses RD. And it uses an immediate and reg file sub RD equals reg file sub PC plus M. Great. All right, now we have an ops system. CSRW, the mint vector. That doesn't seem important. You can just ignore op systems for now. Right, we do have to write sly. SLLI. It's so satisfying to write code like this. Opam. Oh, we got to deal with shamties. Oh yeah, get the shamty out. Logical left shift. We can probably write a smarter reg file that deals with overflows. Let's just write that now. Class reg file. Reg file. Init. Get item x, return self reg sub x. And then we need store item. Let's store item in Python. Magic class Python. Get item. It's kind of like get item, set item. That's it. That makes a lot of sense. So great. Can you hold your tears back just for another minute? She wants your gift back, so we come and get it. What's a friend without a friend? Secrets you pretend doesn't matter. Well, I have friends and I have friends and they all matter and they all care about me. They don't know what that's like. She says they want to fight me. I'm coming home tonight, but now the table's turned. Alright, let's go. And it takes 0 positional arguments, but one was given. Oh, we have to give it a self. Oh, and of course, reg file is an object. But I think actually Python 3 you can just do that. Right, great. All right. Write func3 add. Wait, didn't I write add before? I thought I wrote. Okay, what'd I break? I broke something. What did I break? Who knows what I broke?
I don't even get it. Like, how is it complaining that I didn't... It doesn't make any sense. Oh, God. Guys, you can catch that bug. Okay, let's commit this. Let's throw .swap. RISC-V tests. You guys know how to get the tests. Basic CPU-ish. Push. Push. We have to write ops 51. Oh. Okay. What's an op? Okay. I'm happy we did this in Python first. We're really gaining some experience here. What type instruction is this? This is an R-type instruction. RS2, 435. Oh God, we have a Func7 now, and we still have Func3s. Okay, so we'll keep the Func3 around, and we have a Func7, but Func7 definitely sounds like later problem. So the fun of this all is then going to actually be writing this in hardware, and you're about to find that while I'm, top tier Python coder, I am not top tier Verilog coder. We got a raid. A lot of Lux. Hello, welcome new people. All right, we'll give a little overview of what we're doing. We are writing a RISC-V core in Python. Verilog is not coding. We're writing a RISC-V core in Python. So what is RISC-V? RISC-V is an open source CPU architecture. So most of the CPUs you use are in big computers, x86, and in small computers and in phones, they are ARM. RISC-V looks a lot more like ARM, but it's cleaner and it's open source, and we all know who owns ARM now, so death to ARM, ups to RISC-V. Yeah, that's hopefully enough. So what are we implementing now? So RISC-V has these different types of instructions. They seem to break down all the instructions into these types, and then they tell you about more secret types afterward, which is kind of lame, but that's just what it is. This looks to me like a U-type instruction. That's an R-type instruction. Get rid of that. So now we have a add, right? Func3, funct add. I think it's just this. So we're implementing a CPU. I downloaded a test suite off the internet, and we're just running the first one from this test suite, which is supposed to just check the add instruction, but looks insanely complicated for that. But hey, what can I say? Yeah, RISC-V is hot. We only bring you the latest, hottest stuff on this channel. NVIDIA is a bunch of rent-seeking assholes. They weren't always this way. NVIDIA used to be cool. But, I heard. I won't name any names, but like I heard there's like a guy in the crypto industry who made billions of dollars, and now he's like surrounded by like handlers, and these guys like feed him drugs and bring him to clubs and make him think he's cool, but in reality he's not. And I feel like that's what's happening to Jensen at NVIDIA. Like you look at the NVIDIA stock price goes up, you know, they think, oh wow, that's worth a ton of money. You know, they just think they're like hot shit, and like, I mean, yeah. You know, like here NVIDIA was a nice company, new NVIDIA, bunch of dicks. But that's what fake money does to people. I mean, Jensen's still a cool guy, and I think he can bring it back. I don't think he's gonna, you know, pull a Larry and Sergey, who honestly, I want to talk about two people who fucked the future more than anybody else. Larry and Sergey. And you know what? Larry's sick. I don't blame Larry, but fuck Sergey. I hear he just like parties now and like is a fuckboy. Like, you know, you can do that, but like, you know, just the future of like, you know, the world you live in. Hey, who cares, man? Go to the party. Jaller. Oh, we should write in the jal reg file sub rd equals reg file sub pc plus 4 boss. Because we need to put that in the jaller too. Jump and link register uses the I type encoding. Oh, this is an I type instruction. Ah. Well then, should we write a separate decoder for it? I don't know. We'll figure out how to refactor this first. We'll spend some time refactoring this code before we wait. It's only ops branch. Right, let's just see what's going on here. Oh, it's a BNE instruction. Wait, but that shouldn't be a jaller. Oh, wait, it's not a jaller. Oh, I already went through the jaller. Jump and link register. The target is obtained by adding the sign extended. Oh, we got a sign extend. Just spell it out as sign extend. What do you think? How do I do sign extending in Python simply? If x shift L minus 1 equals 1, I gotta return something else. It might just be this. Probably is right. Equals 1. Sounds right. Local variable offset reference before assignment. And the sign extended. Okay, so this is reg file sub R1. Should I have written a shorter reg file? Like, so I don't have to type out the word reg file every time? Maybe I should have. No, it jumped off the end of the memory. All right, let's change that a little so it's not an assert. If less than 0 or is exception read out of bounds. Maybe my sign extend didn't work.
0. Oh, because it shouldn't be plus equals. It should just be that. All right, we still have a read out of bounds. Reg file sub rs1. Wait, that seems really normal. Oh, okay, that's a jowler. It's the jowl that's messing up. Probably because we didn't sign extend the jowl. Well, let's go to B8. No, that's not right. Do I have to put these in parentheses? No. That can't be right. Did I write that decoder wrong? Okay. That's M10I, we shift that 1. That's M11, we shift that 1. And that's 12, we shift that. Shift that 20. Can't be right. Where's getting that 1 from? That's the problem. Oh, Jibby's wrong. This should actually be 3132, I think. Yes. Great. We just didn't write branch yet. Bro, we're going to figure out why the M1's so fast. We're going to implement all that in our RISC core. And then we're going to, nobody's ever using V again. But I do imagine a Jensen that takes his company back from the MBAs. So I would not, like some companies I think are hopelessly lost. Like you can't fix Google, but you could fix NVIDIA. We just need a Jensen who's ready to be like, yo, guys, the money's a scam. We care about the future. And maybe he'll do that. I wouldn't count him out. He's been around for a long time. All right, so these are func 3s. Branch instructions compare 2 registers. God, we have to do another stupid decode. This is a B-type instruction. I thought they said there was only a few types of instructions. Where'd the B come from? We got a B. Throw some B's on that bitch. Throw some B's on that bitch. Something like that. These are func 3s. BEQ equals that. BNE equals that. Yo, you want to do BNE? Let's do BNE. Never have it at Dane Cook. BG. BGU. We're going to decode this stupid offset that looks a lot like this one, but stupider. All right, so when we jibby that, we shift it 12. We jibby this only down to 25. We shift it 5. Jibby this, and we shift it 1. And we jibby this 8, 7, and we shift it 11. Okay. Compares to instructions if func3 equals, which one do we actually have to write? Whatever's at 2, 7f. We have to write the bins. Func3 bins, BNE. Wait, where's that 0? I don't know what bin. Oh, just, okay, one of the registers is 0. That doesn't matter. Else dump, write func3 if reg file sub rs1 is not equal to reg file sub rs2. We want to branch, else we want to just yeah, we want to branch reg file sub pc plus equals offset return true. All right, we got to write sral. Well, we should do this in to write im sral. So it's not really a sral, it's probably a srali. Maybe that's right. Let's figure out where that is. We're at 2808. That's a srali. Okay, cool. Right, op store. No, does this write to memory? Oh, that's hard. Did we do anything with memory? I don't know how memory works. All right, we're gonna do a store opcode. Store, here we go. Load and store instructions. Looks easy enough. Put them down below the branches. 845. Not bad. How does memory work? Who knows? Just like fucking magnets, you know? How do they work? Alright. Func3 is not actually a func3, it's the width. We have an offset, which we're gonna jibby that. Oh no, we also have to jibby 3125 shift 5. Cool. Loads and the stores are S type. They just made up a new type because S starts with store. Store starts with S. S is for store. Stores are S type. The effective address is obtained by adding register 1 to the sign extended add it to offset. And then what we want to do is we want to, all right. God, is this really how I have to do this? No, we'll just do a write string. I should make it work. Value equals reg file rs2 reg Okay, we store some stuff. We have to write OR. I thought these tests were supposed to be just simple. I'm sure it's an ORI. There's no such thing as ORIs. Too many R's in my ORI. Oh, we have to write a Louis. What's a Louis? I should remember. Load upper immediate. Oh, good. Louis look easy. Great. What type is this? It's the same as an RPC. We'll put it by the RPC. It's probably a U-type instruction. Let's do a Louis. Load upper immediate. Places the filling in the lowest 12 bits with zeros. All right, this is super easy. All right, we got to write the op version of OR. Coding like this is super satisfying. It's just like you like fill things in one at a time. Read out of bounds. Oh, all right, we got another broken jail. Where is that jail supposed to be going? To CPU T-string. Oh, my sign extend is probably wrong. Oh, I don't think I did a sign extend here. This has to go back. Yeah, it's going back. Okay, we gotta do a sign extend. How many bits is this? Did I write good sign extend logic? How do you write sign extend logic in hardware? Offset. 20 bits. 19 bits. Damn it! Doesn't work. None of my sign extends actually work. Is it not 20 bits? Well, that equals 1. Okay, so that should make it negative then, if I type 20 there. Oh, no, it's 21 bits. And what's even worse? Right, so how do I actually do this? We do 1 shifted left 21. And then this minus this. Oh, I think we have to make it negative. Yeah, we gotta make it negative. And this probably like a way to simplify that expression really easily, but I'm lazy. All right, good. All right, so now we're jumping to a load. Is that what happens in CPU to string? Oh, it does. Sweet. All right, we gotta write loads. Loads are like stores, but loads. Or opcode equals ops load. If opcode. Where are my loads and stores? Oh, they're totally different. Never mind. Are they both S-type instructions? Loads are encoded in the I-type. Oh, they're I-type instructions. We know the I-type. Load. Okay, so we just do M. Oh, we probably have to sign extend that too. Just say load that base dest. That's right, okay. The variable value because loads don't have a value. So we don't actually write RAM. Nobody wrote RAM. Who wrote RAM? Nobody. All right, write ops branch func add. Well, it's not really an add, which is the same one as add. BEQ. All right. So we don't just write BNEs, we got to write BEQs. We're just going to say cond equals false, cond equals this. If cond. Right, good refactor, boys. What do you think? Is it a good refactor? Good. 0 is not a valid ops. Oh no, where did we branch to? Branch to here. It seems okay. Oh, I think we're supposed to sign extend that. 13. Great. Oh, look at how much running it's doing. I mean, I don't know if this is just looping forever. I wish they would actually give me simple programs and not all this stupid crap. Like, I might actually have to implement the loads and stores. Switch to the p-test. Are the p-tests better? Which p-tests? Command Paul, do you actually know what you're talking about? These p-tests, okay. Oh yeah, they do look a lot shorter. You're right. Cool. Great. All right, this is testing BlitU, but we can just test add. Okay, cool. No user mode. Oh, that's all this crap's user mode. Oh, we should check privilege mode. That's a good point. Yo, Command Paul coming through, man. Command Paul coming through. You know what? We haven't done this in a while, but congratulations. You, wait, how do I do this? How do I make people VIPs? VIP Command Paul. Congratulations. Thank you for paying attention. So branch is not actually, it's not actually XOR, it's just the same one as XOR. BLT. Should we just implement them all? They're not that hard. BLT, BGE, that should all work. All right, great. All right, we have to write MISC. I don't think MISC actually does anything. I think it's like system ops. All right, 0 is not a valid ops. Unimp. Oh, okay. Well, we have to figure out what an eCall is. Does that mean it? Oh, that just means it succeeded. Oh, okay, cool. I think we'll just return false on system. Is there a difference when you call an e-break?
Oh, it's just this. I don't know. I don't think there's actually a difference. Wait. What's that? Oh, that's CSRR. That's not that. If all the rest of them are zeros. Actually, you know what I'll just say? If, not opcode, but ins equals ops.system equal. Oh, no, we actually want the number for this. Yeah, dot value. Great. No, wrong. Okay, there's an equal there. What are these equals supposed to do? Probably have to like implement this. RISC-V equal. Okay, calls the operating system. All right, so on the operating system, that's great. How do I know like what syscalls am I using here? It's like that one's pass and that one's fail, but they look the same to me. Oh, except maybe the value in GP. You go to a register called mintvec. Oh, so this CSRW mintvec actually does something. Mintvec. Oh, it's the address of the first instruction to be fetched when a machine mode trap is handled. Okay, so great. It's in the priv spec. Okay, all right. Is there like tests for like not priv and not user? Is there tests for idiot? Because I'm idiot. V and P. I'm upset about this priv spec thing. Why are you guys all doing that face? I don't want to write this. Oh, I'm gonna make the mintvec work. I don't have a mintvec. I sold my mintvec on eBay. Counters, eh? Oh, yo, a trap vector. Yo, we gotta make a trap. I get it. Write to host. How do we write to host? Oh, we swore after RPCing. Okay, here's a fucking ring file. All right, fine. We'll do it. Mintvec. This is junk. We don't need that anymore. And we'll say mintvec equals 33. And now I gotta make this CSWI work. CSRW. Right, CSR. But how do I know this is like encoded? CSRRW, eh?
I don't want to have ZSCARs. Can I write ZSCARs?
Are those things op system? Yeah, they're op system. All right, it looks like func3.
You don't actually do that for equal. If func3 equals br1, fine, I'll write them in here. This was all great until these instructions came along. These instructions suck. Like, we were all having a good time. And then, like, we have to implement this. Does anybody else understand these? Like, the other instructions, stupid instructions below this line. All right, great. Like, we were all having a good time, and then we had to write this junk. All right. Func3. If func3 equals ops, no, not ops, func3 CSRW. Oh, I don't even know. It's not even RD. Wait, oh, is midvac an RD? Does that fit? No, it can't fit because it's only that many bits. We gotta write this one. What is this? Oh, it's a CSRR. Oh. Wait, what's a CSRR? It's the same as a slit, which is a CSRRS. Oh, well, very important to write the CSRRS right next to the CSRW. Ah, hey. A, Canada, A. Alright. Let's figure out what a CSRRS does. Source. They modify. Atomic read and set bits. What? I need an M hard ID? I don't have an M hard ID. Oh, well, we gotta write the sat p. I hate these instructions. This is the worst part. No, it's only this crap that's stupid. It's all fine until this. 684. Ah. On imp. 0 is not a valid ops. This is another ops system. Okay. Well, that test passes. Where do I get a list of all these registers? It's not just like one more I can stick in the reg file. That was a lie, boys. I didn't even make that 34. That's the end of the test. The scalp triggers the shutdown mechanism. Scalp? All right, well, it's a CSRW, and I'll say if CSR equals this, print success, return false. Okay. Was the fail one also do that? No, the fail one just does an eCall and then cries. The eCall is the important thing? Wait, it's failing. Oh, it's actually calling fail. Oh, that's sad. It's just failing through to success. Right, we do an eCall here, too. We gotta, like, make the eCalls work. I can't believe I wrote the CSRWs. Is this right? Is this actually how it's supposed to run? Why am I creating crypto-related stuff? Can we ban that guy? Banned. Get out. Oh, the test files aren't committed to GitHub. I just cloned a separate thing. Make the font a little bigger. I don't know. That's the failed eCall. There's that eCall. There's also an eCall here. You know what? Maybe I can read the code for this to try to figure out what it's doing. Just search for RISC-V test if you're looking for the code. No. So it's a lie that we actually have success. We'll get rid of that. Okay, we have to just figure out what eCalls do. It's time to read. Hearts. The eCall instruction is used to make a service request to execution. Sweet. Glad you used TwitchLand for something. What if we go back to the not P ones? Are the not P ones even worse? The V's? These just loop forever. Where am I jumping to the start of fail? That's a good point. I guess I jump from 200. This one here, test 7. All right, so like test 7 is the test that's failing. That's not bad. I mean, we do know which one's failing now. I just wish there was like a smarter way to... Yeah, so right here, that's what's wrong. Throw dump in here. Fails right here. Trying to compare A4 and T2. Oh my god, but I have to name these things time. All right. Which test doesn't work? Oh yeah, we were just about to name all the registers properly. So those are the names, but there's better names. I don't know where they are though. Those are F registers. Where's like A0? Where does it tell me which register? Ah, here we go. Okay. Okay, my Louis wrong. Why not 12? I think it's more than 12. Or I didn't do the M decode right. Oh, I didn't do the M decode right. Yeah, this gotta be a 12. Alright, are we still failing? We're still failing, but now we get further down, and we're failing at 260. Okay. Branch, we compare A4 to T2. A4 is there, and T2 is there. Okay, they're different, clearly. Did we sign extend on the M's? Probably did not. Sign extend 12. Oh, now we pass. I think. Yeah, we pass now. Cool. I really would like to automatically distinguish failing and passing. I guess we can... That 93 is everywhere, though, for all the e-calls. Alright, let's just print reg GP. Which is GP? 0, 1, 2, 3. Reg file 3. Equal 1. Let's go back and let's just break the test again. Not that. I break it before. Break it here. Okay, so if we get equal 21, that's a failure. If we get equal 1, that's a success. If reg file sub e equals 21, is that in hex? 15. Failure. Raise exception. Failure in test. Please check. Okay. So now we have failure in test. Please check. And now if we go back to im and we put sign extend in the jibby. All right, add test passes. Add test pass. All right, let's stop dumping all over the place. Great. We reset that. Don't really need to reset the RAM, I don't think. Man. Where's the memory? Great. No, we won't just test that. Let's do all the tests. Okay. Got a new failure because we didn't implement one of the branch opcodes. I thought we were just going to implement them all. BEQ, BNE. Wait, but that's not all of them? Oh, what's U? Unsigned. Oh, God. I'm supposed to do these things signed? Sign extension should be 32. BLTU passes. Get rid of that break there. All right, we didn't implement XOR and IM. Oh, but the face cam moved back. Sorry. We're gonna implement it in here. I should really actually share those. Should we just like they're all shared, right? Man, I don't know. That's probably how I'm gonna have to implement another thing. Arith funct3 xy. SLT and SLL. SLT, SLTU. Well, it's not a shift at all. Figure out what SLT does. Set if greater than 0. Cool. Guess it's just SLT is the same as compare. SLTU is the same as compare without the sign extends. I guess that's not a right file, it's just that. And SLTU is this. Alright, something didn't work well. Okay, good. It looks like all these tests pass then. Until we get to FenSci. FenSci doesn't work. Let's blacklist FenSci. FenSci's stupid. Sweet. All the tests pass. Not too bad. Why am I printing out all that crap? Oh, over there. So wait, the loads and stores are actually working? Like, but not really. And who knows? Who knows if those tests actually pass or if we're just failing at the, let's add the prints back for eCall. Alright, maybe it actually fails if it ever returns anything greater than 1. If reg file sub e is greater than 1. Failure in test, please check. Okay, then the sub test is failing. Which actually the sub test should fail because I don't think I actually wrote sub. So, you know. Oh, I think that's the number of the test that's failing. Wow, that's nice. So it equals 0 when it starts, and then maybe that's the number of the test that fails. All right, let's check the subtest and see why the subtest fails. Let's turn the dumping back on. Branching from here. Well, let's just like write sub, you know? So sub and add are actually the same. Yeah, that's not, that's annoying. If I can just change to this, it does the same thing. Alright, I think what I'm supposed to do here is invert it if it's sub. Yeah, so sub is funct7. If funct3 equals funct3 dot add and funct7 equals that, then print sub. Yeah, okay, so that makes sense because that's actually failing. What we want to do then is subtraction of RS2 from RS1, which is the same as earlier. No, it's not right. That is right though. Just maybe we have to equal fine. Okay, now it fails earlier. actually. Subtract from RS1. So what if I just do sub? Failure test was checked. Okay, RA is that, SP is that, and we expect the value to be in A4, which is 0. Didn't work. Which doesn't work. Oh no, this just might be... No, wait, sh is failing. Oh, I see, because sub didn't work. It was like some other tests that actually failed didn't work. Okay, now sub passes. Some other tests started failing. Oh. I mean, yeah, I guess actually, yeah, that's fine. Actually, some other test just failed. Oh yeah, get rid of the dumps, because we're actually getting past sub now. Yeah. Yeah, okay, look, sub's passing. Okay. Load and store don't work. Okay. And we know load and store don't work, so that's great. SRI should work. Okay, probably SRI is the same as SRL. Yeah, so it's the same like bullshit as sub. Arithmetic right shift. So again, the difference is that there's a different func 7 for it. Oh, this is annoying. Yeah, it keeps the sign bit. I get it. Well, this is just gonna be a bitch to like implement all in. This is a stupid instruction. Is this immediate that it's failing at? Or the other one? It's immediate. Oops. Okay, well, first off, it's not minus. We want to shift it right. trail fails, but not till much later. I think it's failing because, yeah. I mean, this shouldn't be a problem, but it might be. Alright, cool. Alright, LBU is failing because it's a load. That's fine. Slit IU doesn't work. No surprise there. Why doesn't slit IU work? Are these good instructions? Sets RD to 1 if RS equals 0. Seems right. Both are treated as signed numbers. Oh, I think, well, I don't know if SLT-IU is using... Not sign extend right? Yeah, I probably didn't sign extend right. Except, yeah. I did sign extend. Maybe that's the problem. Oh. You can't have that, I think. My sign extend logic is slightly wrong. No, you don't want that. You can't actually have that though, and that's the problem. I think this is the problem here. You can't have negative 2048 if something's only 12 bits, right? Yeah, that's 0. Problem is if this is who knows how to fix my sign extend logic? Python sign extend. Sign bit equals 1 shift L minus 1 return X and sign bit minus 1 minus value and sign bit. Okay, maybe it's not sign extend. Like you. Oh, it shouldn't be negative. I see. Great. New problem. Good. This is a deeper problem. Let me just do this up here. Or, you know what? No, it's not right. Whatever. See, there's a lot of subtlety here, and I'm doing it wrong, and I'm not thinking this through well. It should be a signed comparison. Okay, all your PC is failing. There's not even a test 5 in that one. Turn dump on. Let's see where it's actually failing. Here. I didn't sign extend it. Oh no, I don't think that's right. I think this is the same as this crap. Same failure. Let's look at IPC. It's a 20-bit, 32-bit offset, filling the, oh, it's the same as this. All right, cool. The JAL test fails now? That's even an earlier failure. YPC forms a 32-bit offset, filling the test to the offset, and then places the result in. Right, that fixes it. Sraz failing. Sraz failing for the same reason this shit fails. Fill fails. Calling straw. What do I do? This is the same, right? Yeah, substra. Oh. I was hoping someone would spot that. That's spottable. Alright, good. Straws work. LB fails. That's expected. What are all these load instructions? Jailer fails? Did I not sign extend? It's probably that. That's what you always get wrong here. No, I did sign extend. Why is jailer failing? God, I thought this was going to be easy. Just have to write this shit in Verilog. I have to think about how we're going to write it in Verilog. You know, a bird in the thinking is worth 2 in the not thinking and just spam programming. What? Oh, it's because they're both the same. Yeah, you gotta, the order of this matters. NV equals this. See the problem? Actually, that one doesn't matter. Cool. All right, I think that's all the tests. Boom! All the tests. All right, let's just write loads of stores. All arith tests. We need a working memory model now. Okay. SD, SW, SH, and SB. From the low value of register, low bits of register 2 to memory respectively. Okay. This doesn't seem too bad. Well, in some ways we have to write loads first. So, you know, we just gotta test LW. LW is fine. I mean, we could write stores, but we wouldn't test it until loads work. So what else is true about a load? Okay, so it's not actually a func3. It's called a width. If the width is 2, I don't think that's right. It's an LW, right? It should be a word. Yeah, okay, so this is junk that doesn't actually correspond to anything. Did I write all those things out? No, I didn't. So it is actually a func3. There's not too many, I'll just write them. I mean, this is one of the things that's going to be subtly wrong, but I'm lazy, so R32 adder sign extend rec equals rec file RT equals sign extend this to 8 LW no, we have LH is this. LW doesn't have a sign extend. Then we gotta put some L's in front of these. Get rid of the sign extends here. We'll add some U's here. Alright, that should make all the loads work. Great. Get rid of that. Boom, first try. I love when I get things on the first try. Alright, let's go write stores. Stores are the same as SB. SH and SW. Yup. Alright. Swag. If we'll do func3. Swag. 3 equals we have to write memory. What is whatever? WS. Who remembers these things? Not me. Alright, we'll throw a B in there. Value and that. That seems right. Did I get this right on my first try? Probably not. This one's harder. It's an unsigned int. Unsigned short. And this doesn't need a thing. Adder, file offset. C. Unsupported operand for bytes and int. Oh, did I type it backwards? Yeah, I probably typed it backwards. It's kind of stupid. I don't actually like that convention. We're just going to switch it. Yeah, you should have done this shortcut in Vim and it would have been faster. Alright, cool. Start to work. Alright, fine. We'll figure out what fences are. Who likes fences? I think fences are dumb. In a world with no houses and doors, we don't need any windows and gates. Oh, fences already work. Alright, great. I mean, I didn't write a fence, but it just works, so that's great.
Okay. Boom. It all works. It flushes caches. Well, you know how many caches I have? None. We got a direct-to-memory architecture here. In a world with no toilets, who needs flush? Oh, it's fence. It's not even flush. That makes no sense at all. One of my more nonsensical git commits. All right, cool. But look, all the tests pass. Oh, I love when tests pass. I feel so satisfied right now. All right, so that was like 200 lines of Python. Now how many lines of Verilog is it? So guys, now you're gonna run into this problem, and it's that I don't know Verilog. It's a Linkin Park line, bro. All right, let's go. I'm gonna have to write the same thing in Verilog. Well, okay. So let's first think about a few things. One, we need a pipeline. Let's refactor the Python to look more like Verilog first. Oh, I'm not too sure we need sign extend here. We do. Why? I don't get it. I don't get why I need that. Yeah, so we're going to refactor this Python code to do something more sane. And then we'll be able to write this in Verilog pretty easily. Even though I don't know Verilog. Okay, so RD is always in the same place. If we have an RD, it's there. That's going to be an optional write back of the RD. I don't know why I deleted the other things. CPU pipeline. Okay, instruction fetch, instruction decode and register fetch, execute, memory access, register write back. So we shouldn't be writing these registers all over the place here. Let's say something, we'll say npc equals reg file sub pc plus 4. Like here, we'll change this to npc. We'll get rid of this return true. This is the first thing I should refactor. What's also cool about this is I can now get rid of this NV hack that I And like, it's great now that we have tests. Oh, see, now one of the tests failed, so I messed something up. Oh, well, I didn't actually do the write back of NPC. So we're going to say here reg file sub PC equals NPC. Get rid of that. Stupid. Okay, something broke. Yeah, so NPC equals reg file sub PC plus offset. I don't understand why that doesn't work. If any more returns. What did I do? Even the simplest thing is failing. I didn't even change that much. I set the default NPC value to be reg file PC plus 4. Which is right. But I bet, you know, like every mistake we make here is one less mistake we're going to make. Reg file PC plus equals. PC equals R1. File PC plus offset. No. Let's try dump. Maybe it'll become obvious. Split you. Feeling it's 68. What? Oh, that's just because I'm more. Like 494 equal. That should be okay. Oh. Wait, what? How was I doing like that before? Oh, I had this. Oh, okay, that was so dumb. Actual exit. Alright, fine. We'll call this the PC write back refactor. By the way, if someone wants to put a pull request up on this that automatically runs these tests, I would merge. Okay, so we have to change every place where we access reg file. And we'll create something called pend. We'll say like pend equals none. I'm going to bring RD up to here. It's always the same RD, which is nice. And if pend is not none, reg file sub RD is pend. Great, all tests will pass. We'll call this the RD write back refactor. Okay. Instruction fetch is a read from memory. Instruction decode. The classic. Yeah, okay. I'm gonna put load and store down here and say these are the memory access step. See, they're gonna take longer. You see the problem? Because like that's not free. Can't cite examples, though there are RISC-V compliance tests under dev. Yeah, it's okay if they're not exhaustive right now. Like we just got basically an idea. We're gonna have to fix bugs on the in the Verilog probably too. So like, I don't think there really is an instruction decode. Are loads really I-type instructions? Oh yeah, I guess they're the same as these. Oh, that's cool. All right. I think we want to add alt to arith and put this in the arith decoder. If alt should work pretty well, right?
Except there's not really an alt. There's only an alt for add there. Because there's no sub. There's no sub immediate. Yeah, otherwise they're all 0. Oh, wait, SRA is also there? Yeah, okay, that's fine. So in the immediates, that's, yeah, cool. And then, so SRI is overloaded with SRL. What do I do about just normal SRA? Oh, it's SRA. Okay. If alt, do this. Oh, I was still setting reg file there? Oh, that's bad. But yes, we should be able to get rid of this now. This actually should be penned. Cool. Refactor arith. All right, should we write some README for twitchcore? RISC-V core first in Python, then in Verilog, then on FPGA. Notes. Execute. All right, I think RS1 and RS2 are always the same. Yes, when they're available, they are. Okay, so what we're gonna do is we're gonna move the register fetch. Yeah, okay, we have to move the register fetch outside. That's cool. Even if it's useless, it's okay. We have to move all accesses to reg file basically outside. I see why people say this is so well thought out. Like, look at how easy this is. Move RS1 and RS2 outside. Okay, now we're going to move. So this is not just going to be instruction decode. It's going to be instruction decode and register fetch. So we're just... Did I do a get status? I'm not doing get status. I want to confirm that the only places we actually use RS1 are in here. So we're going to say VS1 and VS2 equals reg file sub. Okay, and then instead of saying reg file sub RS1, we say VS1. VS1, VS2. You guys get why I'm doing this? The same way that we moved the store of the registers to the bottom, we wanted to move the fetch of the registers to the top. Sweet. All right, we're just gonna do another VPC, so we're now fetching regfile PC. All right, so I think we can refactor that stuff a little bit too. We'll do it in the same refactor. Notice how we're fetching again. We fetch for NPC here. And like, that shouldn't actually be right. Maybe what we want instead of this is we say like, that's not right. I mean, I'd like to use the same arithmetic core. Reg read refactor. Who likes my, is that alliteration? Alliteration. Yeah. Pipeline hazards. You seem to know a lot about this. I don't really know what that is. So I think we don't really like that as much. Okay, is func3 always the same? It is, so we can bring that out into the decode.
Okay, so actually we should move all these jibbies out as well. Dependencies between instructions when each stage is parallel. Wow, this is all getting super hard. 31 stage pipeline. Damn. Oh, hazards. Yeah.
Okay. I think we should move this sign extend down to here. Same with this sign extend. Same with this sign extend. And this sign extend. This sign extend can go here. And then we can decode all the immediates up top. But based on the different types. Because that's not a real sign extend. That's gonna just like be in the ad. Yeah, look up twitchcore. I should probably write a script to fetch the tests, but I'm hoping one of you can do that. Do we have any polls on twitchcore yet? Pull requests, boys, pull requests. I want the tests to be automatic. Run better tests, find bugs. You can run this. This is a super accessible project. It's one file, it's a CPU. Okay. So like, whenever we have I-type instructions, we're using that same immediate. So I'm just gonna bring it up here and call it IMMI. Cool. When we have U-type instructions, how many U-type instructions are there? Let's go take a look at this thing. Call this guy MU. Cool. Do we have a U type? I type, S type, B type. I hate J-type. I guess func7 is the same thing always. The two places we use it. This is not even the same type. This is a B type. So U type can be a B, a U, or a J. All right, we'll just call this one MJ instead of offset. MJ, MB, CSR. Well, op system or I-type instructions. Okay, they're I-type instructions. So instead of CSR, we just call this one MI, which makes sense. Great. Okay. So now we're all doing all the decodes up here. We're doing the register fetches here. Setup. This is looking like something we can actually put in the Verilog. Okay, now we probably want to use the same arithmetic engine for these. Right, like we're not going to implement a new adder. It's the same adder, right? So let's just call arith func3.add VPC sign extend false. Does it work? Great. That doesn't go into pend. This goes into I mean, okay, these are cute. Look, it like swaps what normally happens. But it does put it into NPC and not to pend. This is pend equals NPC, but we'll get there. Let me just create a we'll call it cond vs1 vs2 func3 vs1 vs2, just so I can like refactor this up here. This is the real value, boys, learning how to refactor, you know? Like, you watch me code, and like, learning to code is good, but learning to refactor. Cond func3 vs1 vs2. Like, what I'm doing now is thinking. Like, obviously these refactors don't change anything. I'm just checking that the tests run exactly the same. But what this does is makes it so like I can think about how to actually make it in hardware. How many of you have some Verilog experience? If you're getting no module named elftools, you have to pip install elftools. You people with Verilog experience, do you understand why I'm doing this? or at least some hardware experience. Branch up here. Actually, yeah, that's good. Branch goes up there. Those are the things that said NPC. Yeah, it's a RISC-V core in Python. All right. Do you want, like, you know what? Text. Create new. Writing RISC-V core in Python. All right. Oh no, where'd my text go? It's gone. Let's try again with new text. RISC-V core in Python. Yeah, okay. Is everyone happy now? Is everyone happy? We have to move this last offset for a S-type instruction. We gotta remove the last jibby. At least move it up. Do I already have S-types? Call it MS. I'm gonna order these in the way that they order it here. Okay, there is no MI, but MS is real. Okay, now my question is, do we actually want to move the sign extends up top? We might. So first off, let's see if we can do this. Yeah, I think we want to move the sign extends up top. It's the same thing over and over again. Cool. It was pretty good. Let's see if we actually moved all the jibbies. All right, we moved all the jibbies. Is every place I use MI sign extended? Or could be? Yes, it's fine. Great. Okay. Let's sign extend jibby 12. And let's get rid of all these sign extends for MI. Oops. Okay, it didn't work. That's not good. Let's first undo. That's not something to be sign extended, right? C100 12 bits. Oh, maybe that is the problem. Because yeah, that's the only place that doesn't have the sign extend. So that's like not even a real one. That's a hack. It should just be negative. Yeah, negative 124. Sweet. Okay, let's move the other sign extends. So MU is an interesting one. MU, we're actually going to put the shift in here. All right, and then we can write all this decode logic in Verilog pretty simply. MB sign extended to 13. One place we use MB. MS get sign extended to 12. What other M's do we have? MJ gets sign extended to 21. Great. Okay, are those the only sign extends left? Okay. Well, those ones are different because those are used in the RAM pipeline. Move sign extends. Look, I'm making my channel more accessible to people. Am I not? So I think we want to refactor this NPC thing a little. I really want to set pend to that, but set a flag in those cases. What is an inops branch? Is It would be really nice if VS0 was, if if RD was 0 in a branch instruction. It's not, it's part of the immediate. You see, it'd be nice if it was 0 because then, oh my God. Yeah, the call needs return address. I mean, yeah, it needs these. And like, that's why I'm trying to like work out like, there's like one register write back really. And always there's two register write backs. There's a PC register write back and a PED register write back optionally. I really want to put these in pen. And then I want to change RD to be PC, but not exactly. Complaining about the color of my text. Can have blue text. Does everyone like that? The fetch always assumes next PC till you have to do a pipeline flush on E. Oh no, I have to do pipeline flushes? Oh, I don't know how to write any of this. Oh, you're right. You're right. Oh man, because if it branches, the next fetch is wrong. Oh, I should have paid attention to computer architecture. Pipelining isn't that bad. You can start really simple. Can I though? Hack stall fetch when you see branch. Well, what if we don't do any stalls and we just like, you know, it like does an instruction and then is done and it like does another instruction and then it's done and it like does another instruction. I like that. No, I need a hazard detection unit. Damn, how do you guys know all this? Yeah, it just takes 3 cycles to run an instruction. We do a fetch. That's single cycle. Yeah, what do you think? Single cycle. That sounds fast. You just had a unit class on processor architecture. Yeah. Should we go back to speedrunning Pokemon? Who wants to speedrun Pokemon? Also, we got to get some food. Let's do 8K. Is that 8K? I don't think that's actually 8K. I think that's 8K. That? Too little. 8KB is good. It's 8. You should just be doing a Pokemon Yellow? No, I'm using a different camera. I'm using this one. I'm gonna make some pasta. What does sign extend 32 do? I don't think I actually want to sign extend. I don't know. I know that I have to get rid of those pluses. And I'm gonna have to put the Okay, so like we do want to we want to put this stuff in pend too. But we don't actually want to do the register write back. Yeah, like my little trick of like pend being null is not very good. We want to like set some bits. Should be pretty fast though once we get this. You could use the register write back. What's blue spec? Oh. All right, let's look up pipelines. Memory access we need to do. Okay. So we're gonna set some flags. Not if pend is not none. We're gonna say reg write back equals false. So we're gonna do PC write back equals false. And for these, yeah. Okay, we'll get to that later, but either way. Right now, everywhere we set pend here, we're gonna say reg write back equals true. Damn it, loads are hard. PC write back equals true. Pend is PC equals true. Get rid of NPC. I'm gonna put pend here. Pend is PC. If reg write back, if PC write back, not pend. We actually want to say RD equals NPC. And here we say if pend is PC, that. Not NPC, VPC plus 4.
Okay, that broke something. Oh, because we didn't say write back equals true here. Okay. All right, so we have three flags. Reg write back, PCRD write back. The other thing we could do is we could do it if it's a branch instruction, set RD to 0, and then we can get rid of that flag. And we can like always effectively make it. See what I'm saying? And get rid of PCRD write back. We can always do it if we have pend as new PC. Pend is new PC, we say this and that, else reg write back this. Yeah, that works. Is that implementable? Yeah, probably. And we don't actually have to set pend to none because we never actually check pend. We don't use it. Okay, cool. We're making fun. the canonical pasta? Who's like a fan of spaghetti? Answer, nobody. Oh, a couple chips. Stale chips. A good pregame for spaghetti. Spaghetti even. Talk about spaghetti. Well, what about some spaghetti even? No, it's like spaghetti's overrated. Okay. Got hot cream. Yo, could you get the... Are we back? Alright, cool. I hit the plug again, but it was different. So now all of these things should be replaced with calls to arith. Except it's MB here. This one is MI and VS1. This one is MJ and VPC. Let's make sure those are okay. Yup. Alright, so that's a call to arith. I guess I could make a custom one there that just does nothing. Well, actually, I don't need to do...
it's like super thin. Spaghetti's the dumbest pasta, and I don't know why I ever bought it. I'd like who's ever, you know, if anyone annotates this video with timestamps, like this is the part of the video where George goes on a rant about spaghetti. 3-minute rant about spaghetti being a stupid pasta. Just doesn't fit in the pot well. So you guys can't see this, but I'm using a spatula to push the spaghetti into the pot. Now there's like one spaghetti everywhere. It doesn't spread out. Ziti. Ziti is a good pasta. How long does spaghetti take to cook? I never made spaghetti before. Because it's stupid. 4 minutes? Wow, spaghetti cooks fast. Maybe that's why people have it. I put it in and there. Break it in half. Oh wow, we lost a lot of viewers when that shit glitched. Or maybe it's just my thing that's wrong. No, we actually just don't have viewers anymore. No, the viewers are gone. Was it the spaghetti rant? Did I upset? Oh, the viewers are coming back! Woo! Okay, here we have to just write pend func3 add bss mi false. That might really be today's stream. You guys could see how to push this into Verilog, and maybe we'll do that on the next stream if we continue the twitchcore project. But this was fun. We learned the RISC. We have to okay, so we have to build the arithmetic engine, the cond engine. Oh, here's something interesting. I can move this up here, can I? I can't. You guys see the difference? And then I can just say pend is new PC equals cond. Oh, yeah, good refactoring. Command Paul, nice having you here. I know the viewers are all coming back. See, right back, do store. We don't have any hazards in our pipeline now, do we? Oh. You know what? If I do that, then I don't need this anymore. Sweet. Oh yeah, we just gave that on reg right back. Cool. And it just like switches them based on pend is new PC. Oh, that's clean. All right, so now you can see like the execute engine is going to have these outputs. It's spaghetti time. Now this is actually looking mad clean. I don't know how we're going to do hazards yet. I don't know how to implement stalls. And then once we get to out of order execution, I really know nothing about what happens. But we definitely need out of order execution to get maximum speed, like the M1 chip. Alright, spaghetti, spaghetti. Marinara sauce for the spaghetti. Oh, that's a lot of sauce. Oh well. Yeah. Well, sauce doesn't even stick to the spaghetti. All right, here in this S-type instruction. That. Cool. Alright, now pend is just the output of arith every time now, right? Only exception is when we do these loads. I hate the why. Why fuckers? I call them why fuckers. They ask why. It's a dumb question, bro. The standard why rant goes like this. If you start asking why too many times, you'll just sit in your bed and watch anime all day. That's what happens. That's what happens to why fuckers. Can there be pipeline hazards if there's no pipeline? That's a big brain idea. What text do you want bigger? You want the text that says RISC-V core and Python bigger? I am still here. But am I going to leave tonight for LA? I think I probably should. I think it's time to get on the road. Is it time to get on the road? I don't know. This is the only one actually that's not the output of So now for reg write back, we can actually just set it to a big OR of a bunch of ops, I think. Are we far enough along that we're just ready to go to the Verilog? Where are the chicken tenders? Maybe we'll make chicken tenders later. Let's move this crap down to useless land. Like R-type has that, I-type doesn't. For that alt bit in the arith. Dial on, dial on, dial on, dial on, and dial on. Well, it's hard to make fast CPUs. It seems like the kind of thing, though, with pipelines that you could like get AI to do for you. And by AI, I mean search. We'll do a little refactor here. We'll just, no, we won't. Do we actually want to do that? So it's actually based on Func 3. I'm happy. I'm very happy with that. Okay, I think it's Verilog time. How do you code Verilog? That's a great question. I have no idea. But I do know that in TinyGrad FPGA, I actually have a whole implementation of a RISC-V processor. And we're not going to look at it too much, but we are going to just like remember syntax. Wow, that's a lot of stuff. Last thing you might want to add here would be exceptions. I know it's not pipelined. Oh, do you want me to write like the Python so it emulates the pipeline? I could, but I don't care to. I mean, I could. I could write that as like a pipeline, but it's not actually pipelined in Python. Okay. Module. What should we name the processor? What should we name the processor? Hot pasta. Martha, Candy, RISC. Hot CPU. Taylor. Big titties. Y fuckers. Oh. Small titties. Oh, well, we got all varieties of titties up in here. I like Candy. Candy's a good name. My processor will not grow up to become a stripper. Alright, so we're gonna have inputs to the CPU. Clock. Reset. And we're gonna have an output reg trap. Those sound nice. I'm gonna like put the memory. No, I should probably copy that. I don't know. We shouldn't copy too much. Okay. Wow. But it's just like give me an idea of Verilog syntax. Quadrants. Oh damn, this is complex looking. Yeah, we want to say things like always at pause edge of clock. Oh, and then I think we have to begin the model. Do we have to begin the module? I think we have to begin and end. Okay. Candy is a low performance RISC-V processor. Okay. So first we need to write the decoder. Module. Let's get rid of this. I don't think this does anything. Decode. Oh man, are we building a Harvard architecture or von Neumann architecture? I don't know. Always at pause edge of clock. Okay. We have an input instruction. What did I call it here? I called it ins. We have an input ins. Oh my god, we're gonna have to do things like multiply. Wait, is there a multiply? I don't think there is. Did we have to write multiply? Sweet, I don't think we did. We only have to write like add and shit. Oh, nice. That's right, write a software multiplier. Who uses multiply anyway? Okay, so the input is an ins, a 31 wide ins, and then like output reg opcode where's the register file? This doesn't have to be. This is combinatorial logic. Opcode is how much long? If it's 6, 0, then that makes it 7. Oh, just 6, 0. Oh, that's easy. So then we can say things like opcode, and this shouldn't even be combinatorial. Assign opcode. See, I told you guys I don't know this. Yeah. No, we don't need an always a pause edge clock. I have done this before, so I do kind of know how to do this. I'm not a total idiot. All right, assign opcode 0, semicolon. Decode. How do we instantiate a module? I can make wires. How do I compile Verilog? Verilog simulator Mac. Icarus Verilog. According to these instructions, you can install it. Oh, this is great. Can I brew install it? Brew install Icarus Verilog. All right, let's go. Verilator is nice. All right. How do I use Icarus? Stephen Williams, help me out. For a noob. All right. That looks good. It's all great, yup. Stimulus. How do I run it? Simulating with Verilog. Here we go. iVerilog. Oh, now we're talking. iVerilog CPU.v. Syntax error, I give up. That's the worst error I've ever seen. You know, if Clang gave errors like that, they can write like a parser. You know what? I give up too. Oh. End module. Begin module? No, there's only an end module. Oh, you don't begin modules? But you do put a semicolon at them, and then you type end module. Oh man, the syntax of this language is very modern and good. Okay. There's some ways that I can display things. Display. Display. Bob. Nope. I can't display Bob. Can we monitor Bob? Monitor Bob. Invalid module item. Let's look at the top. Do I have to instantiate it? Or maybe I have to call it top. Invalid module. Might want to use VCD. What's VCD? Is this another? Verilog VCD. Oh, do I have to tell it about candy? Can't find any candy. Okay. Ah, GTK wave. What's VVP? Oh, we have VVP. iVerilog-ODSN. What's A.out? Oh, is that my Verilog? Did it compile it? Wait, that's got to be illegal. How can you compile Verilog? Run. Start Verilog. Run. iVerilog run. Verilog VCD parser. I don't know about this. Dump file. Invalid module item. VVP run. Invalid module item, eh? VVP sucks. Verbose. Huh. I see. All right, after I VVP it, then what do I do? How do I add a clock? Oh, I have to like test clock for Verilog. Test bench clock. I kind of remember that. I give up. How come the display doesn't work? Invalid module instantiation. I copy and pasted the example. All right, module. Do I need an initial begin? And that doesn't work. Or maybe I need an initial begin. Opcode is not a valid L value in decode. Opcode is declared here as wire. Oh, because you don't do that in initials. I get it. Oh, okay. We're making progress, boys. Look, it printed out work. Oh, yes. Oh, yes, we know the Verilog. All right. Module test bench. We don't have any inputs to test bench. And module. Begin, we'll say reg clock. Clock 0. Always number 5, clock equals not clock. And then we're gonna make a candy with a clock and a 0. And traps are stupid. Oh, I get it. That's not even a part of the module. It's just a reg clock. I just have more syntax errors. Oh. You know, like this thing could like do something and like tell me, okay, that's not how you make a candy. Candy. Malformed my ass. Reset for bitch. All right, let's go. Is it because of the always? Oh. Port 2 expects 1 bit, but got 32. Oh, I could do something about that. You get a B. It's not that. 1B0. Yeah, I remember Verilog now. Why you malformed? Syntax error. See? Initial pound 100 finish. Oh, I need a semicolon. Work. Always at 5 invalid module item. Begin end. Work. No more work. It doesn't get to no more work. But just if I do that. That's strange. Oh, I guess because you can't put it after finish. All right, let's just remember if I remember any Verilog. We'll do something stupid like reg
So to 0, count equals 0, always a pause edge clock. It's not a sign in, is it? No, it's just like this. It's like count plus 1, and then no more work, and you can display count. No more work 10. Doing work. Sweet. Oh, yes. Oh, I'm remembering all the Verilog is coming back to me now. All right, now we just need to write a CPU. That's the easy part. We got the test bench working. Spaghetti even. Spaghetti does not hold heat very well either, I must say. Spaghetti has many downsides, and one of them is its lack of ability to hold heat. All right. Is there a way to write sign extend? That looks like a mad crappy sign extender. This kind of stuff's not even really useful. We're gonna have to have ports on the RF. No, I don't think decode should actually be a module. Can make them wires. No, we did Verilog already, look. We did Python already, now we're in Verilog. Okay. We need memory. Where do we get memory? ROM data. ROM. Oh, look at all these options. You know, I might want to spend some time reading some CPUs before I try to write this. like I could write something, but I think I'll be able to write something a lot more elegant if I think about it for a little bit. Let me think quickly. What is there anything we could show off with the Python? That should be a fully functional RISC core in the Python. I see kind of how to do it. It seems frustrating, and like RAM seems frustrating. Now I understand why, like, there was a debate between, like, all right, so one of them, I forget whether it's von Neumann or Harvard, but you have the instructions in a separate place. But all those, well, a lot of the tests should still work. Just load and store won't work. Okay, we don't have to implement load and store right away. We do have to implement a reg file. And we do have to write something that's going to write out the contents of memory. How come some of them are bigger? Oh, there's bugs in the memory. All right, bugs. Too small. It's too small. Okay. 16 KB. I don't know. Like, I don't know if that stuff's gonna work. 16 KB might be like massively huge. Okay, oh, you're right. I have to update the title. Verilog. All right? I understand now why people were getting confused. I didn't update the text. Well, okay. Yeah, you also have these incredibly stupid, like, read mem h. Verilog is picky about the read mem h. Okay, so we can't actually just write that. We have to
bin ASCII hexlify. B to A hex or hexlify? Right must be stir, not bytes. Okay. Now we can load the RAM, load the ROM with like this kind of stuff. ROM words. Oh, how many words is that? Oh, that's a lot of words. I feel like it's just going to be slow. How many words is 16 KB? 496. Alright, we'll put this inside the candy. 4095. And we'll read memh instead of firmware.hex. We'll read, get rid of test cache. Test cache. We'll try to test add. Not enough words in the file for the requested range. Excess hex digits. Why are there excess digits? Not enough words in the file. Do I have to separate them with enters? I might. It might actually be that stupid. God, I don't even know how to do this. I split it up every 8. That stupid? Expected stir instance bytes found. Oh yes. Now it's slow. That isn't right. Right? Okay, it works now. Great. Yeah, you got it. Oh, white space matters. White space matters. Okay, we have ROM now. Always at pause edge clock. Oh, we need the registers. Just that should work. All right. It's not even ROM. That actually should be RAM. Hey, If it loads in fast enough, it's fine. Okay. Regs sub. Wait, why did I get 31? Oh, should PC just be special? Instruction reg. What did I call it? I get another name for it. I called it ins. Ins. All right, does that work? Syntax error. Semicolon? No more syntax error. Okay. Can I use display in here? I can. X. Why is that X? It's because PC doesn't have an initial value. Don't forget semicolons. Always begin. Shouldn't it be 1 the first time? Now it's 1 the first time. If reset n. How do you do? How do you do it with like if PC equals 0. Oh, not reg sub PC. What am I doing? ROM sub PC. Oh, okay, we're getting somewhere. Verilog display hex. Cool. Great. Is that actually the first? Cool. All right. Great. Now, you know how in Back to the Future you got to think fourth dimensionally? Well, it's actually the same thing when you're coding in Verilog. You got to think fourth dimensionally. And if you're not ready to think fourth dimensionally, you know, Verilog's not for you. Okay. If reset PC 0. Instruction fetch. Okay, we want to write a decoder now. A lot of this stuff is just... It's like there's like big combinatorial logic that just kind of says, depending on the op, depends on what we feed into the arith. Reg write back equals opcode equals jal. Or actually, I can just say in. Jal, jaller, PC, Louis, op, im, Cool. Testo pass. Panda's new PC is a little bit trickier. That does actually have to happen at the next time step. Do load, we could just say opcode equals ops load, opcode equals ops store. Panda PC actually goes there, load still can go. Cool. Actually, here's an interesting thought. We can combine all the ims into one, because only one im is ever used, depending on the instruction type. Im equals right? So we can look up the instruction type and then we just get im. We can do the decode every time, but we'll just end up with im, and that's really nice. In fact, in some of them, we're not even gonna set, we're gonna set im to VS2 if we're doing an opcode op. Now the first argument to arith looks like it's always either VS1 or VPC. Do we ever use both VS1 and VPC? Yes, we do. Right there. Otherwise we could just assign it, but no. Okay, we need there's a thing called there's a latch for that. I guess even there's a latch for which im we're going to use, and it's the same thing. We of course didn't write the thing that's going to pen the. Have I written any other cores before? No. This is my first try. We'll have the im selector. im equals mj if I hate this because it's like the same crap. But it is fundamentally, it goes to the same like arithmetic unit, depending on how you're doing the im prepare. You can say alt equals and op equals or sweet. So you understand that refactor? Now we have vs1r equals vs1 if op VPC if opcode in JL or branch else vs1. Notice how all of these are the same now. Oh, well, something broke when I did that. Did something actually break from the M's? No. Don't understand why that doesn't work. Oh, out PC. Okay. Maybe this is actually part of execute. Arith func equals func3 if opcode in ops op or ops im else func3 add. You guys see what the big refactor is going to be, right? Soon we're going to get rid of all these if statements. For mu opcode in Louis else vs1 argument of type ops is not iteral. Oh. Great. Now we should also be able to put this here. Great. Oh, we can get rid of these. Replace them with alt. All right, all right, all right. Pandas new PC equals opcode in ops jal jaller or opcode equals branch and cond. Wait, where'd my other what? Oh. How'd the test pass when I did that? That's scary. Okay. So the only ones we'll keep are this one. And now we don't have anything left anymore. So it's just that. Boom! Yo, that's crazy. That's crazy. Look at that. Look at how we just deleted all those if statements. All right, now we just have to write that. Sushi. Python refactor. Boom, look at that. That's like that's really compact. Do you see how this goes in an FPGA now, right? think this stuff actually goes in execute. Yeah. Just Python 3 or 4 loops. I'm actually just going to refactor this to be like this. I'm going to call this VS1R. That's a stupid name. We'll call it arith left. No. You guys, I'm not just writing random. It's not random Verilog, right? It's not random refactoring. What I did was I refactored the whole execution engine into this, right? Instead of having these like weird if statements that I don't really know how to implement in Verilog, this is now something that's very implementable in Verilog, right? So we've already written the first stage of the pipeline here, which is the instruction fetch, very easy. Now we have to write the instruction decode and register fetch. But we need a sign extend. We can write something like wire opcode, wire func3. That's not right, it's actually that. Func7, wire 31, mi, sbuj. Syntax errors. How do you make wires? Why is that wrong? Oh, because I'm in the always in pos edge clock? Alright, maybe this. Yeah, you can't do that always at pos edge of clock. So like, okay, wire opcode equals ins 060. Yeah, okay. This is, I mean, this is fine. 14, 12. 31, 25. Alright, now we need to write these other things. Verilog sign extend. There's like a way to do this pretty easily. Okay. So we do, yeah. Ins. I can't believe that stupid sign extender that guy wrote. So mi is something like 31 this. But we also want to repeat ins 31 how many times? I don't know. I guess, no, that's not that stupid. That's like the right thing to write. What is signed? Can I just do that? That'd be nice. Invalid module item. No, of course it's not going to be that easy. Why doesn't this guy's thing work? Alright, so what's this gotta be? Like 24? Oh, need one more of these? Cool. For MS, it's just concatenation of, how big is it? 12? It's going to be the same as that. But here we're going to say ins 31, 25, and here we're going to say, oh, this is like cleaner to write in Verilog than Python. No, so I don't want that. All right, cool. That compiles ins B. This is 13, so we only do 23 of these. Ins 31, 30. Here we do ins 8, 7. Ins 30, 25. Ins 11, 8. We actually also need one more. We need a 1B0 here. Cool. This one's not sign extended actually, and I don't understand why the Python needs that. We just say 12B0 here. And then MJ is the biggest bullshit. We're sign extending to 21, which is going to be this, but for, well, let's just leave it at that and see what it complains about. Ins 1912, ins 20. I guess this is why they do this weird encoding. Like, it's really easy to write in Verilog. 3021. Right, it's gonna complain hopefully. Yes, but I don't think that complained about the right thing. Well, okay, maybe it did. It just has a stupid error. So this should be 11. Invalid module item? What? Oh. It actually doesn't matter if that's the right size, so I might have gotten some of those wrong, but either way. Great. More Verilog. Alright, now we got to do the register reads. So those are actually in instruction decode and register fetch. So we want reg sub ins vs1, vs2, VPC. We don't need VPC. I do, but I don't know. Okay, compiles. That's not right. 24 and 30. Okay. Now we move on to execute. Wow, it's shorter in Verilog. Can you believe it? Drag right back. How do I write that? There's no way to say in like that, is there? Case statements are a big deal. Do love myself a case statement. Case. Well, I really want... Actually, maybe there's a commonality to all of these when you look at the actual bits. Yeah, it's pretty complex. Opcode. These are all the ones that have write back. And it'd be like really nice if just one of the bits was write back, you know? Okay, you know what? Let's just case. We'll just, you know what? We'll just do a big case for the ops. It's actually not that bad. Wow, so we're back to having something that actually looks more like 6B. Translate that from the Python. Oh, I'm so glad we did this in okay. Case opcode. Let's look at a case statement. Begin end. case. Oh, is it not 6? Oh, it's 7. Can't count. Okay. We have to make a wire. Oh, I can't use a wire because we're in an always pause edge clock. Okay, actually, we'll just take this out of the always pause edge clock. This can go up here. Wire M. Okay, so if it's Louis, M, sign M equals M. Does this work? No. Able to bind parameter opcode. But what? There is a parameter opcode. Oh, I can't bind it. Why doesn't that work? Does it work if I do it always at the pause edge of the clock? M is not a valid L value, so like, does it work if I do it like that? Yeah, okay, fine. Okay. If it's a load, we use I. If it's a store, we use S. If it's an OutPC, we use U. If it's a branch, we use B. If it's a JAL, we use J. If it's a JALer, we use I. If it's an M, we use I. If it's an op, we use VS2. And miscon system are stupid. I don't know how we're going to support them. Great. Make a few registers here. Arith left. Arith func. Arith left equals. VPC and JAL, branch and AWPC. Can I do this? And it's like a default? No, I guess not. Oh, there is no VPC. PC? Maybe I can then. Yeah, these are the defaults. That's fine, I think. Arith func equals add, which is just 0s. Unless we're in op or im, then we say arith func equals func3. Func3. Great. And this does like override, right? I'm not getting the syntax wrong. Arith left im. He never gets that. Go to 0? Shouldn't be 0. That doesn't make any sense. Oh no, output is 4. Arith func is 0. Okay, 4 is fine. 4 should be what? Oh. Is the endianness wrong? Endianness is wrong. This is... God. I actually wrote code for this already. All right, now it's 6F, and now we're setting some stuff. Okay, good. Oh, you know what? Let's print out PC while we're at it. Oh, this is PC. All right, PC's a whole lot of zeros right now. Actually, we should set PC to this. 32.h0. And we can say something like no, actually, how wide should ROM be? Not that wide. It's only oh, we'll just shut up. Doesn't work. That works. Great. So we're ignoring the top bit. Okay, cool. All right, and then, yeah, so that's going into arith. All right, great, that all works. We actually have to write the arithmetic unit. Decode is not its own module, but arith can be its own module. Where's the arithmetic unit here? Inputs are func3. We have an input called alt. We have an input called X, then we have an input called Y, we have an output called out, case, func3, You guys always waste time talking about Vim. I could use a different editor, you know? Like, it's not that big of a deal. Not like that I don't have any cases in my case. It's an input. I don't get it. Do case statements have to be in pos edge clock? Okay. So this is add I out x plus y. Does that work? Come on, Verilog. All right, cool. Which other ones do we have to do? To do sly. Okay. Maybe it's because I'm not instantiating it. Can I write like junk here? No. Srili. No, SLT. SLTU. XOR. Sril. Wait, there's a normal one, right? It's not just the I, right? So is this or and no, which is wrong. It was all good until I added these guys. No! What happened? Oh, did I get rid of end case? Alright, the only bad one is XOR. Oh, there's like a special Verilog XOR. Yeah, XOR is like that. Oh. No, it says I can do XOR. No, I forgot a semicolon. Arith. I misspelled it. Alright, let's instantiate the arith here in the executor. Clock. Func 3 goes to func 3. X goes to arith left. Y goes to in and out. What did I call it in the Python? That's some stupid name for it. It was like pass or something. Pend. Malform statement, eh?
What do I do?
Why doesn't this work? Copy the syntax of candy. Is it mad because those are some of them are wires and some of them are regs? Was Func3 the wrong size? What's malformed? Did I forget a semicolon somewhere? Anyone see a bug? The only thing I can think of is that Func3 is not a wire. Alright, we'll call it next Func3. And then always at positive of clock. Wait, actually that's not even the right thing. We're supposed to not even... God, this is wrong. It's not supposed to be Func3, it's supposed to be arith funct. I don't actually think that's the bug, but it's still wrong. I mean, it's possible I have this backwards. It's supposed to be like this. Also have a bug in my module instantiation. Oh, did I not call it? Did I need wow? No. No, I wish this thing had reasonable. Can I say output reg here? I can. Are you assigning a wire inside clock? Alright, can I make an arith A that I don't connect to anything? No, I can't. Don't understand why this is any different from when I make a candy, though. Module candy. Module arith. Alright, I wish I had another Verilog compiler so I can check what, like, give me a real, Oh, I know what I'm doing. I can't put it in the, always at pause edge clock. God, I wish it would tell me things like this, but I'm pretty sure that's the problem. Yes! Oh, look at this! It added this and got this! Woo! We did an addition! Oh, man. We did an addition, boys! Oh, is this ever going to compile to a chip? I see why there's a difference between Verilog and Verilog you can synthesize. Okay. We're not writing any memory stuff now. Where do I set Pend as the new PC? All right. Oh, we need conditionals.
Reg append is the new PC. Set it in Jowl and Jowler. And here we set it to the output of the cond unit. We have to write the cond unit, module cond, input clock. Yeah, this is where like I'm gonna be like wrong, but it's fine. That sounds like a later problem. All right, so cond has func3 as an input, which has the same inputs as this thing. It does not have an alt mode, and it has output reg out, just like that. And module conc, give it a clock. This actually just goes to func3. We'll have to deal with timing in a little bit. Which are the two inputs? VS1 and VS2. VS2. And then out equals cond. Let's just say wire. Did I call it cond? What did I call it there? Call it append as new PC. Append as new PC cond. Compiles. We have to just write it. Where is it? Where is it? Where is it? All right. These are the ones we have to write. 43, go. Always at pause edge clock. 44, end case, end. Begin, BQ. Out equals X equals Y. I have no idea Verilog can actually build these things. BLT. I don't know the difference between compare and signed compare in Verilog. BGE. I'll just copy them here. Okay, well, we need semicolons. We can start with that. Great. Okay, I don't know, maybe my compare unit already works. Sweet. Now what do I have to do? I just have to do register write back, right? We'll do loads and stores later. Now we do reg write back. Oh, we have to be careful with this one though. Reg sub PC equals. Yeah, inline F. Some nice inline Fs, right? Yeah. Regs PC equals. If pend is new PC, then pend. Otherwise, VP. I didn't make VPC, did I? There is no reg sub PC. It was just PC. But we have to really wait till that's. Yeah. We'll pipeline it. We're gonna need that anyway. VPC plus 4. And then for the actual register write back, I don't know how to make this conditional. I guess I could just do reg write back. Did I set that one, right? Did I reg write back? No, I didn't. Reg write back. We've got to set that in the ones that do it. Let's document it in Python. Should I open it somewhere else? There it is. Reg write back. Jaller. Jaller. YPC. Louis. Load opening. It's actually most of them. So we do reg sub RD. Did I even get RD? I don't think I did. Penned is new PC. Then we do VPC4 like that, and we have to deal with the special case for 0 somewhere. All right. Well, that totally broke my CPU. Because you can't set PC down here without totally breaking your CPU. Yeah, see, like I need something like an always at pause edge reg write back. Actually, that might work. Delay this. Special about clock, right? Let's say arith ready. I need some arith ready thing. No, it shouldn't really be that. The arrow's always ready. This is stupid. That's not where we want to put that. Okay. I think we're going to build a processor that runs exactly one instruction. And that's the stream. Guys, you got to think fourth dimensionally. This is Verilog. Yo, did that just do something? Look at that. Look at what it set PC to. It just executed a jump instruction. That's crazy. Yo, can you believe it? Can you believe it? You know what? Instead of writing this stupid step thing like this, we'll just make a little register that's like this. And then if you're resetting, it's step equals, yo, we just executed an instruction. And then we can just say down here, step equals step plus 1, but then it's not always a pause edge. I don't like this anymore. Guys, I don't know how to do pipelines. Someone told me about hazards. We didn't deal with any hazards, but we executed one jump instruction. Let's just examine the jump instruction in all of its glory. Where are these tests? They're in like... yeah, like here. Oh, yes. We jumped to 48. Which is not 24. And this is wrong. So we actually jumped to the wrong place. But we did jump. Look at how PC changed. Oh, that's a good point. I could do always at neg edge reset. Begin. Yeah, oh, that's wild. Reset N. Cool. Cool. Now, wait, why is it jumping to the wrong place? This is because probably I made a typo. What kind of instruction is that? It's a 6F opcode. 6F is JAL. So I made a mistake in the JAL and the, yeah, I know the mistake I made. Yeah, this needs a 1B0 here. Boom. Now we jump to 48. That's the right place. That's where we were supposed to jump to. What happens at 48? It looks angry. LIRA 0. Okay. Oh, you know what else we have to do? At pause edge of step 5, we have to reset all the steps. Wait. How'd that even work?
Yo, how many instructions did we just run? That's like 4 instructions, boys. I don't know why we get X's. That's because we like made mistakes, but I don't know. This is pretty good. We got like a decent CPU going here. Yeah, I'm pretty happy. A candy.
Would you like to implement a candy? All right. If we do another stream about this, we'll actually we'll finish the CPU. We'll get this to compile. How does it take 4 cycles to execute 1 instruction when there's actually 5 stages? No, there's only 4 stages. Only 4 stages. 1, 2, 3. Memory access is later. We didn't actually do memory access. We'll need to add one more. We'll need to add one more stage when we want to do memory access. But yeah, you see, look at this beautiful pipeline. I avoided all hazards by just not pipelining. Oh yeah, who needs hazards when you have not pipelining? No, there's no pipelining. CPU runs. No pipelining. It just like steps through, and then like when it's ready, it does like the final things. It does the outputs that actually like do anything. Yo, this is really cool. This was so much easier than I thought it was gonna be. I'm sure there's tons of bugs still in the Verilog one. So what we have to do is get the same printout. Okay, so we've written this Python emulator, and we can call the Python emulator the ground truth. So what we have to do is get the Python to print out basically this same stuff. And you know what? We could even put this in here, and then it's only going to print out when it actually runs an instruction. I can change this up to like 500. We'll give it like 500 clocks. It looks like the CPU does eventually crash. Like hard crash with like X's, boys. Like not like a soft crash. Like this is a real crash. Yeah, that's the basics of writing CPU in Verilog. There's probably another 5 hours of debugging. After write the actual memory interface, then make sure it can actually be implemented on a CPU. Like, I don't know how good that adder is, right? I just put plus in Verilog. Who knows what that does? Can you do that on a... I don't know if you can even do that. I guess you can. I don't know why we get X's. We'll leave it at that for now. So we're doing a full pipeline stall. Yeah, avoiding stalls from hazards is where it gets tricky. I don't know how hard that's going to be. I see what it is now. What do you mean structural Verilog versus functional Verilog? Like, this stuff should compile to the chip. I don't see why I wouldn't. This is some big combinatorial thing. I do have an FPGA right here. On my other stream, I got all of the tools running on Mac to actually compile an off-the-shelf RISC-V core. So now we have this one. I can call this Arith. I should call it ALU. And what's a cond? Is that an ALU? Is that part of the ALU? Do I use both cond and the ALU? It might actually just be the ALU. No, I use the ALU during branch. So it's a separate unit. Comparator unit. Cool. Thank you for watching. Enjoy the rest of your day. Have skills. Be happy. Boys, I wanted you to be here for the moment of truth. On FPGA. Yeah. Yeah, I wanted y'all to be here. So I got it all working. You know, I felt like I left you hanging. I felt like, you know, were there really only a few bugs? Yeah, there were really only a few bugs. I fixed them all. Look at my commit history. First off, we gotta get some chicken tenders in the oven. And then once the chicken tenders are in the oven, we are good to get it working on the device. I already put a little bit of work into it. I was like lying in bed and I'm like, yo, I'm just chilling right here and I'm having a good time. But I figured you guys would want to see this RISC-V core in one day. This is some Twitch Slam quality shit. This is some Twitch Slam quality shit. Alright, so I got it all working. I got the Verilog implementation working. The test pass. I think I fixed mostly the last bug. I had a few bugs in my encoding here. I had a few things that I just didn't think through great. It's still not pipelined, so it's a completely... every pipeline is basically a stall. Every fetch is basically... there's no pipeline. I just didn't make a pipeline. We can try to pipeline it. How many viewers we got? 67. All right. Chat, you're all in early, so if you want to ask questions, you can ask questions. It's how many lines? It's 233 lines. I separated out the test bench. So here it is. Like this is it executing this subtest. The subtest was the last one to get working because I mixed up the Louis a little bit. But then I fixed the Louis and it all worked. That's actually off by 1. It's the initial. Yeah. It's actually right before the right back. Huh.
regardless. I got to actually say the traps. So you'll see, like, let's say I break the Louis again. You'll see that this fails with error code 15. I put the Louis back, error code 1. So you already saw some of this stuff in the TinyGrad stream, but I have a compiler working, and we have an FPGA, and I wanted you guys to be here when we actually click download. So let's try it out. Saya01, thank you for gifting subs. Yeah. Well, if I break my board, then we don't have a stream anymore. I'll just plug this into my laptop. I also figured out why my monitor was glitching. I was kicking the plug. I shoved it into the wall good this time. It's not a compiler. We built a RISC-V core. So let me copy over the stuff from TinyGrad, which lets you download stuff. Prog to fun twitchcore, and we'll copy over digital into RD to fun twitchcore, and now we'll program. All right. All right, it's blinking the LEDs at some really insane rate, I think. So let me, I saw some demo code for this. So this here is the CPU. It's 234 lines. This is that test bench that executes when you run Go. And then this is the top level module. So let me steal something from Atasoc top. You know, I tried reading the Atasoc core. Like, it's so complex. So much stuff here, and like, I'm not really sure why. Like, I don't like the way that they did. I don't think they did this stuff nearly as nicely. But I don't know. Maybe there's probably a reason they did it their way, and it's probably because they have pipelining, and I do not. And all the subtlety of microprocessors actually probably comes from pipelining, so don't trust me. Check Atasoc top, and I wanted to copy in this clock divider. So right now the CPU is running at 50 megahertz, and it can run at 50 megahertz, but the problem with 50 megahertz is you can't see anything. So let's figure this out. If there's 2 to the 23, 50 times 1 million divided by 2 to the 23. Okay. So this should run 6 instructions per second if I change this over to clock width. Let's recompile and program. We can try a Pokemon speedrun after this if you want. We did a RISC-V speedrun. What is Verilog used for? Verilog was used to write our own custom chip. All right, it's downloading. All right, all right. Look, it's executing. This is PC. Whoa. Look at that. It's executing. Let's see if reset works. Oh, maybe switch 1? Or switch 0. Ah, okay. All right, good. Look, we reset. And now it's like broken because it's stuck in reset. But now we're going to take it out of reset. Yeah, look at that. It's running. Oh, yo. We actually made it work. That was so easy. This was the shortest stream ever, boys. Look, and I can put it in reset with that switch.
Now it comes out of reset. The CPU is now running at 6 hertz. You heard me right, that's hertz. And remember, it's not pipeline, so it's actually more like, slow. RISC-V core on an FPGA, woo! Yeah, I don't know what else to do. That was just too easy. I'll just commit this. Works on hardware. I had to make a few changes in order to get this to compile, so I couldn't use like these pause edges on anything but the clock. So I put register right back in like this. That should be the last assignment, so that should be good. And then I put reset in like this. Yeah. This is an FPGA running the RISC-V core that we wrote this morning. It passes all the tests except for the memory test because we didn't implement the memory yet. I can reset it if I flip this switch. That's this switch here. Now the chip's being held in reset. And I flip that back. And we're back to running. All right, we should actually make sure it's getting to halt. Let's make it run a little bit faster. Let's go for that kind of speed up. And then we're only gonna set the LEDs. Okay, there's 4 LEDs and they have 3 colors each. I think we can go there. Like that. And that's going to be 11 minus 3 plus 1 is 9, so that's just going to be 8 to 0. Okay, the bottom bit's a PC. We sped the chip up. We're going to see if it manages to get to the halt state. It recompiles so fast using a completely open source custom tool chain. Props to all the people who did this and made this possible. It's running the router now. Programming now. Yeah, there we go. Look, now it runs fast. I don't see it going into trap, though. I don't actually know how these LEDs are wired up. Maybe they're not wired up how I think they are. See, look, it's executing the first instruction, which is a branch, but it's being held in reset, so it can't execute the instruction. And now it can go. I don't understand, though. There's 11 LEDs. I don't understand why. Why that didn't change. So now we should write a DDR memory controller and get Linux to compile for it. I don't understand why any of these are turning on. This is probably the bottom of PC here. Why is that blue light turning on? That can't be trap. So that eventually gets to trap. Yeah, so that red light there is trap. But I don't understand why. Why is the blue one turning on? I don't think it should. Maybe I don't understand how the LEDs are wired up. Let's just take a look. Oh. Oh, okay. This is a scam. See, look, all the red ones are wired here. I see. Yeah, they did some like redoing of this. Don't worry about it. What we can do is just this. Yeah, so basically we just didn't set the red LEDs to anything except for this red LED. These LEDs are kind of poorly laid out for this. So we'll leave that one on LED 0, but we'll assign LED 3 through 1, the first, those bytes, and then 5, 7 through 5. You see how it's laid out? These ones, 3, 4, 5, and then 6, 7, 8 will go to 9 and 11. And we will leave out 0, 4, and 8 so that this LED doesn't turn on until we hit halt. And just because we can, let's speed it up a tiny bit. So when it halts, it means that the test has finished running. Yep, this is running the RISC-V test for subtraction. It's a RD100T. So what I expect to see is this LED not turn on until it finishes. And it's done. That's why the red one's on. There you go. It might eventually loop around or something. But yeah, so you see the red one all the way over there, so we can reset it. And now we'll let the program run again. It's running the test, and when that red light turns on, it means the test passed or failed. We don't really know which one. No, I'm almost sure it passed. Boom. And then the other lights are just mapped to PC. So the PC register from the RISC chip. Yo, when I was doing from the transistor to the web browser, I thought writing the CPU was going to be hard. Took a day. You know, having a tool chain that isn't terrible for FPGAs makes me want to do that course again. What do you guys say? In November, come off the grid, we'll learn a real
you know, computer science. Buy a bunch of these boards. You can buy the tiny ones. You don't need the good chip. Yeah, no Coursera. You're gonna learn in real life, you know? No online virtual bullshit. Great. How many viewers we got? 248. Not so many. How did CPU V came? We wrote it earlier, but I just finished it while I was off stream. But like, you can read the diffs. I didn't cheat. Yo, it's still running. After it traps, it continues to run and just run through all the 0 instructions. Reset. Run. Wild. RISC-V is brilliantly designed. That's the other thing that makes this stuff possible. Like, I don't think you can write an ARM chip like this. Let's just look at the ARM instruction set. I don't even know what even has ARM anymore. I was reading this article about breaking up the Ivy League. Let's see, so this PDF from back in the day. You got another number, bros. I don't know how I remember that. Oh, this is nightmarish compared to RISC-V. Though I do remember writing things for this. ARM is also patented or like copyrighted or something, so you can't really make ARM chips. I mean, you can make ARM chips, but then like you don't really own them or something. The ARM instruction set encoding. No, I mean it's like similar. It's kind of similar to RISC-V. You have to do like rotates and stuff. But like, I didn't understand things like why it's so important to have like the destination register in one place. And how unimportant it is that all the things be contiguous. Like this immediate encoding is no problem at all. Yeah, there's some ASICs. There's some RISC-V ASICs now. So the problem, I was just looking up like M1 pipeline. I read this article. Like the Apple, they're claiming that they can do look ahead of 630 instructions. Like super scalar to the moon. I don't know. I guess I imagine it's a lot more work to go from like writing a little processor to like making it scale. Wow, it's beautiful how simple that is. What do we want to compile? Well, like part of the problem is we only get like a crappy serial port.
Quantum computers aren't real. I don't know. I just wanted you guys to be here when we did the download to the hardware. RISC-V is going to change the world. I'm actually quite optimistic. Well, also, like, I barely used any of the FPGA for this. It's this board, but with that variant. Yeah, it's this one. This variant's pretty good though, too. Wow, it's crazy that that's so much cheaper. Make it a 60 core. I mean, yeah, we could put multiple of these cores on. But all right. Do we want to think about pipelining? Well, so what pipelining is, or we should at least probably write the RAM. Yeah. No, and then you have to like deal with all this stuff for hazards and stuff. Oh, it's so hard. Do I offer a course for programming? Should I start just like scamming people out of money? Should I just become a scammer? Bro, why do you need my... You know how much free shit there is on the internet? I just wrote a CPU today. I read some manual, and then I wrote a CPU. First in Python, then in Verilog, and then I got it to actually synthesize and run on this FPGA. To be fair, I did a lot of the legwork on the TinyGrad stream. I don't know what to do with money, boys. I owe the government money. The only reason I owe the government money is because I made money. I owe $15,000 in like Q1 fucking taxes, you know? The only reason I owe them that money is because I made money. And with more money, more problems. I'm gonna be homeless and, you know, make computers. Just make a video just describing your journey in programming. You know, there's a word that comes to mind, but you're not allowed to say it anymore. So, you know, that's the word that comes to mind when I hear shit like that. You should get a much larger FPGA. The real bad words, boys. The real bad words. Oh, we'd like to command Paul. Yeah. So you gotta do like this kind of stuff. You gotta do it. Instruction fetch, instruction decode, RISC-V pipeline. Well, I'll just go through the same stages. Oh, implement the M and F extensions? Let's see what they are.
We can just look if you guys want to see the bugs. Oh yeah, okay, so the first bug that I fixed was I forgot to initialize the registers. That's why we were seeing those X's. The next bug was that I actually was not accessing the ROM is word indexed. So yeah, you gotta do that. Then the next bug was that you don't actually ever write to the 0 register. So I think there's a few different ways to implement this. There's probably like some neat like hardware way to make the thing actually like not writable, but I just wrote this, which won't do the register write back if the destination register is 0. I made some typos in the encodings. It's a little weird. So this syntax is not like Python, it's inclusive. Python is exclusive on this one. So if you do like in Python, like x sub 1 colon 0, it actually is the same thing as x sub 0. Well, that's not exactly true, but you're only going to get it's not going to include the one element. It might keep a shape difference, and that's why it's not exactly the same. But the shape here doesn't even seem to matter. So I made a few typos here. I fixed those because it's inclusive on both sides in Verilog. What did I do here? Oh yeah, I just added in traps so it could exit. And then I refactored. So I was using this pend as the new PC cond in my instruction decode stage, but it's not actually ready by then because like the register fetch is there. So if I ever want to get real pipelining, I have to move that. So I moved that. Which one's this? Refactor PC. Oh yeah, fix minor Louis bug. When I switched to do subtraction instead of addition, the way I still put the Louis, so the Louis is load upper immediate. It uses add by default in my ALU. So I just set the left side of the ALU to 0. You know, 0 is the identity for addition. So if I didn't do that, it was just whatever was left over in arith left. Or actually, no, I think I have a default for arith left, which is, yeah, VS1, the other register. So that was meaningless junk, which made that instruction not work. And then, yeah, this made it compile for the FPGA, but it actually didn't work because you can't do these always at neg edge reset. These edge triggered things on Xilinx have to be put through like a buff G or something. I'm not sure exactly what it is. No, that's not exactly true because it worked okay on my divider. So it's something else, but you can't do this is all I'm saying. Maybe because both things were trying to write to it and it just kind of didn't do anything. Oh my God, there's some tabs in here. Let's fix that. I don't know if it's no ET or ET. I always get it wrong. Tabs are disgusting. Yeah, so I couldn't do the at pause edge. I had to put it actually in the clock trigger, and then you guys watched me do that. So, boom! It's the new Twitch Slam, bros. It's the new Twitch Slam. Remember the time George wrote a computer? This probably is, I don't know. Twitch Slam's probably harder. Yeah, so are there good? Is there any superscalar RISC-V that's open source? Oh yeah. We were gonna look up these other instruction sets. I know what I have this over here. She said, "Can I come over? I'm sitting in my driveway." Oh, if you want multiplication. Oh yeah. Oh, I think the little one might support multiplication. Oh, my candies are almost ready, boys. But this doesn't look too bad. I don't know, maybe it's really hard. What do I need, an integer divider? What's in the A instructions? Oh, tmux. Well, I don't even have working memory, so that's not a problem. Floating point. That all looks tricky. The tenders are ready. How's the progress since the beginning of the stream? This is my custom RISC chip running on real hardware. Passing all the tests that don't involve memory. Let's see if we can get a VRAM to run. Put some memory in here. No, tabs are disgusting. And if you have a different opinion, you're wrong. How big is a tab? Yeah, that's the one I'm looking at now. Verilator, I used Icarus. I wonder how fast it is. Superscalar RISC-V, IMC. What's C? Oh, compressed instructions. You mean thumb? One of the most powerful things that I think RISC-V is going to enable, though. A lot of times, what you want to do for like neural network accelerators is you want a programming model that looks like a CPU. If you could figure out how to add these things as instructions to a CPU, like access to a big floating point multiplier. So, one of the other things that's on this board that's cool is it has a network port. All right, so I wonder maybe if there's something I can download. What I really want is just like what I really want is a PCIe bus that lets me talk to the internal memory. RISC-V is a new architecture. What's decimal floating point? I don't know. I like this one. It's kind of like the Apple one. Support AXI 4 bus. I'm not really understand what these buses actually are better. I don't made a big little risk that's actually useful yet. Not that I know of, but see. No, I don't want to make an accelerator. I want the core to be the accelerator. What's an issue queue with a ROB? Is that the thing that Apple has a ton of? ROB, reorder buffer. Well, this thing has a 64 ROB. Apple has 630 ROBs. The service wafer engine is so stupid. The service wafer engine is the pinnacle of like investor idiocy come to AI. Actually, with an FPGA, you can download more ROB. What's the XL2? A Buick Enclave. Oh, that's cool. You guys know I've been thinking about starting an AI chip company. I think we clown him like comma clown him. It's another one of these, it's another space where all these people are massively overfunded and they're not producing anything. And like NVIDIA's the Mobileye. You know, we got some great synergies with comma. Yeah, Elon has his own chip. I want my own chip. If Elon has a chip, I want a chip. Yeah, I'm not even working on the investor pitch. We're gonna have good synergies. Elon doesn't sell his chips. I'm gonna sell everybody chips. For 4 times what they cost to make, y'all still gonna buy them. Because NVIDIA's charging like 20 times what they cost to make. No, I want to tape out an ASIC. But do it first on FPGAs. No. I've never fabbed a chip before. Is it painful? It's called tape in. It's funny. LU? LU is beautiful. Okay? LU. Get rid of that A. You don't actually ever want that A. It's just e to the x. My, Okay. I just want to ask you guys one question. If the activation functions were slides, which one do you want to ride? Right? Like, leaky LU is just the worst slide. Like, you just keep sliding, but only a tiny bit. You have this big discontinuity right there. Yeah, ReLU just kills you, man. Sigmoid is a nice slide, but it just doesn't have the same beautiful runoff as the LU slide. The LU slide is a you can't see it. Oh yeah, I made my camera big. Alright, I'm not here to talk about activation functions. Yeah, yeah, you gotta scoot to get going on sigmoid. There's a big Q at the top of the sigmoid. Any accelerator that doesn't have CCIX, that's this thing? No, I don't like... I'm not thinking like that. What I really want to do, it's CXL, look up CCIX. I don't have any PCIe. Just network, some super fast RISC-V chips, and big packed in neural accelerators. You know, just like I love paying Synopsys from the Phi Guild all my money. I didn't know the Phis were owned by a guild. Yeah, their network's not AlexNet, it's a ResNet because they can't do efficient nets because their thing's not efficient for that. QSPI RAM? Bro, you want big bandwidth. Now, if you had like 10,000 QSPI RAMs, yeah, well, you know. No, Cerebus is super stupid. I want a high performance RISC-V core with like out of order execution superscalar shit that has a bunch of extended instructions that are the ones I talk about in TinyGrad. No, all general compute on board. Like, yeah, the basically I want a RISC chip that's an M1. Yeah, okay, boom, the Berkeley out of order machine. Is this still relevant? +90 megahertz? Oh, and it uses this chisel stuff? No.
these are the kind of things that like you get so far removed from the hardware and you build out architecture research. Reverse engineer M1, build clone, be rich. What do you think of that plan, boys? Reverse engineer M1, build clone, be rich. I just need a lot of ROBs, you know? I just take that one off the internet and increase the ROBs. There's only 64 ROBs. If I had 10x more ROBs, no, I can't believe ARM is better. I think you could build a really good RISC-V. Like, it's the same stuff, pretty much. All right. So we need a front end. It must include dragons. We need an 8-wide decoder. We need 630 ROBs. We need 354 perfs. 384 FP perfs. Good size TLBs. Samsung canceled the M6 core? Why'd they cancel it? Oh, they went back to crappy ARM cores. When's Apple going to switch to RISC-V? You know Apple hates NVIDIA, right? Apple hates NVIDIA ever since the GPU wrong soldering temperature fiasco. And they made Apple look bad, and Apple here disregards the norms and chooses a large and fast L2. Takes 16 cycles to access the L2. L2 is around 15 cycles everywhere. L3 is around 50 cycles. They're waiting on Chinese regulators for approval. Is that actually true? The Chinese regulators have to improve NVIDIA buying ARM? Why? That would be sad if that were true. Wow. Do you guys remember when like America ran the world? Those were nice days. Hey, maybe the Chinese will have some balls and tell NVIDIA no. How are we going to feel? How do we feel living in a Chinese-dominated world? I don't know. Chinese, may they be better hegemons than we ever were. You know, social credit scores in America too, they're just called credit scores. VLIW stupid. 4 decoders. Wow, okay. That's so sad. Who made variable length instructions and thought that was a good idea? CISC crap. I want a chip with like 64 of these Firestorm cores on it. But RISC-V Firestorm cores. Xeon Phi. Well, yeah. I mean, Apple does kind of cheat with their, They're 5 nanometer cheaters. Well, I want someone to make a RISC chip, but with my extra instructions.
I don't know. They just wrote 5 nanometer on a thing. They didn't make any 5 nanometer chips. I love my M1. I hate big little. I only want big. Jim Keller designed like all of these. It's IPC. Micro apps are stupid. Oh. So I want to understand, like, okay, so what's a front end? Like all this stuff I read about pipelines is like simple crap. What's a front end and what's a back end? Pipeline, RISC-V, front end, back end. I'm not bullish on Tens Torrent. Not unless they come out with a different chip. Like, the reason you don't hear anything about the chip is because it's bad. If people have good things, they tell you about them. Even NVIDIA, there's like all these docs on the A100. Like, you know what it is. What else has 5 nanometer chips now? The high silicon Kirin. The Kirin 9000. Out of order. Okay, it's a 4-wide decode, out of order, superscalar design. It can fetch 4 instructions and 6 mops per cycle. Oh, they only have 160 ROBs. Oh, they have a lot of mops. System Verilog has a video called Overview of VSLI. That's not what I mean by front end and back end though. I mean like dual issue. All right, the architecture of a single, like that's nice. I like understand what these things are now. Like we have a fetch, we have a decode. Oh, you do the hazard detection, the decode. What are CSRs? Oh, control and status register. Okay, so that's what I call cond. I think I call that cond. I'm going to rename, instead of Arith, we should call it ALU. CSR, a common name. And then, yeah, we put the mem access stuff in there. TLS offload NICs. That's cool. Yeah, I guess the NIC should really be doing most of the SSL stuff. All right. The 5-stage processor in the pipeline is divided into the instruction fetch, instruction decode, execute, memory access, and write back. In addition, the processor has a control unit and a control and status register. The processor is a 32-bit single issue processor. Okay. So what does dual issue mean? That means it runs 2 instructions? All right, I do kind of want to start writing the pipelining stuff. Nice graph, bro. Dual issue runs slower, it uses more power, and takes up more. However, the negative impact. Dynamic branch prediction. Oh, also, yeah, shouldn't this RISC stuff be 64-bit and not... just want to understand what the back end and the front end are. Subscalar processor. Oh, that's what I built. I built a subscalar processor. Subscalar. Trading at a premium, trading at a discount. You have a superscalar processor. I have a subscalar processor. I wonder why are these people talking. Scalar. Fundamentals of superscalar processors. Yo, computer architecture is so cool. Thanks, archive. It's a download. I kind of want to buy one of those M1 iPads. But then it'll be like every other iPad I buy and then don't use. Whoa, they were only getting 0.1 instructions per cycle? I'm getting like 0.2. I bought my keyboards here. It's downstairs. I'm gonna build my own M1 chip. Books from the 90s. Pipeline depth. Pipeline stall. We now know what those are. Oh, ILP stands for instruction level parallelism. Well, that makes sense. Whoa, these people are thinking in terms of gates. RISC-V superscalar. Dual pipeline. Oh, God. I love Sci-Hub. Okay, so they seem to treat PC not like a register at all. Which I guess is a good point. Are there RISC-V and NXLers? Can I buy this? LG Neural Engine. No, I can't buy any of this stuff. You think there's one on Amazon? There's a microwave. Is there any RISC-V on Amazon? There's a book about RISC-V. There's a few books about RISC-V. Speed M1. RISC-V IoT. Oh, the Maxduino. Oh, yes, I very much trust this. Don't make me try to build books again. Oh, junk. RV32X. This is interesting. A RISC-based shader unit. This is kind of what, is there a spec for this? All right, I think we gotta just write pipelining for our CPU. Look at Sci-Fi's U84. Is it open source? Accepting lead partners now. So no. Yeah, done. What's GBC? Gothboy click? Ooh, big hit on the beat.
I liked that first one I was reading that like talked about how it's the... What's this? Yeah, okay. So, I mean, I like this basic 5-stage pipeline. Renaming. Yeah. Reorder buffer. Robs! Oh, see, I like this. This is good. Speculation. Hardware-based speculation was born. And many bugs existed because of it. Boo! Superscalar static. In-order execution. Branch predictors. Ooh, the perceptron predictor. All right, Len 5 front end. So the front end seems to be fetch and sum of decode. So let's first change it to simulate.sh, and then I want it to run like multiple programs. How do I do that? Well, I guess I can move the memory out. I mean, we kind of have to, maybe we should do the memory first, and then we'll do the pipelining. I don't want to have a subscalar chip anymore. What's this? Dual issue. Oh, they have issue. Two instructions per cycle. Oh, this looks pretty cool. All right. Let's throw some to-dos up on twitchcore. To-do. Add memory support. Make pipelining work. Add M instructions. To do later. Many ROBs like M1 go very fast. Superscalar dual issue in order 6 or 7 stage pipeline. What is this? PC? I just want like one super test that tests everything. Why do they have to be different files? Is there a better test somewhere?
The money's fake, bros. You make yourself a slave to the money, you're just a slave to the government. Wow, like look at how fast it's running now. Once we get our pipelining to work. What's GC? What is GC? Is that the G? Base ISA, we use the abbreviation, G, for the IMAFADI. Oh. I see. Guys, come back to the people who know things. It's a hardware verifier. Oh, glad to see people are still supporting Plan 9. Yo, you know what would be a great troll, man? What if we like took Plan 9 and sold it to investors and then posted a YouTube video making fun of investors because we sold them Plan 9? It is from outer space. This sounds like my hit TV show, To Catch a Bike Thief. It was going to be like To Catch a Predator, but the problem was that everyone hates child molesters and people are surprisingly okay with bike thieves. So, like, you know, that's the problem. People are okay with scummy investors. That's the problem. It's so satisfying to reset it and let it run again. Yeah, Plan 10. What are these atomics? I see. Wait, so this is a whole TVN. I should just... Is there one that doesn't, like... Can I make the whole thing? Ooh, benchmarks. Oh, RISC-V compliance. All right, all right. What do we think of this? We want to make sure my RISC-V is compliant. Number of the test. Great. Now this is huge. I don't know how to use this. I think we're better off trying to figure out how to iterate through multiple of these. Let's see, loads don't work. Now I need some way to run all the tests. I need that to be like a variable. Oh. Does that work? Well, okay. You know what? Here's something I want to do. I want to move the ROM outside anyway. And this should be okay. I just want to look at the naming conventions they used. They didn't do it for the ROM, but they did it for the RAM. Yeah, mem valid, mem adder. Okay, whatever. Output ROM adder. many bits is that? Input ROM data. Let's make this work on the simulator. Test bench. Always at pos edge clock, ROM data, ROM data. ROM sub ROM adder. Like that. Okay. Seems right. Assign ROM adder to PC. What was comma? Wire reg ROM data wire ROM adder. This comma import declaration list. Yes. Sign how you do that. I think it is. It just doesn't like that. 13. Unable to bind. Why? Ins, it's a register, so we'll just change it to a wire. Oh, okay, that works. Cool. Now the fetch is moved outside. At least now we can put that read mem h inside lots of bullshit. But let's just make sure it continues to work in the synthesized version. I know I'm doing clock div there, but it shouldn't matter if it's faster. Oh yeah, I could trigger on both edges, of course. I'm not sure where I'd want to.
Maybe you never understood how to translate to actual hardware. You just need something to compile it to hardware. So it works. Well, now I should at least be able to do. I don't even know why I did this. I mean, I really need like a 2-port memory. Are VRAM single cycle? Dual port RAM module. Does dual port just mean it can read and write? Oh. That's cool. Still didn't really fix the problem. It did move it into here though. Like now I can like change what I'm running in the test bench without changing the real code. Yes, okay, here's trying to do the load. I was trying to load that address. Does that opcode be load?
Yeah, dual port RAMs are cool. All right, you want to make loads work? Let's make loads work. It's not actually ROM. That's kind of a lie. Call it mem. What was I adder? What was D adder? It's probably a better name. Is it Harvard or von Neumann? We're building a von Neumann architecture. I knew Harvard sucked. Now we got to write memory access. So the memory adder is just append. So assign. Wait. No, first off, this should be I. But we can assign dadder append, and then assign. That actually doesn't work, but. Not ins, okay. So D data should be ready by this point. I think I should be able to say this. Makes it look a little simpler. If pend is new PC, did I write the doing load? No, I didn't. I called them something in Python. Do load and do store. Memory access later. If do load. No, that's here actually where I want it. This sets D data based on pend. here that I want to say if do load else. Data. Made it pretty far. A lot of the loads seem to have worked. None of the loads work, what happens? Yeah, only gets to 5, but alright, it's pretty far there. Alright, so that's load. Yeah, that should be good. Is that not what it expected? Chat behaving. Okay. The only thing I can think of, well, actually, let's take a look at the load example. And then let's go look at instruction. What? Oh, did I load the wrong one or something? Like I loaded the P. Should be fine. Oh, did I implement NOP? Don't know if I did. Louis that. Add 15. Is that not what I got when it loaded? Alright, I'll print that out as well. Instead of printing pandas new PC, which is kind of stupid, I'll print d data, c.d data. No. That looked close to right. D-data worked, that one didn't. Wonder why. Pipeline should have plenty of time to settle. Let's just make sure it actually showed up. RISC-V tests. Oh, I'm looking at 64 first off. Test cache. Look at LW. Yeah, okay, that looks correct. This is the load opcode. Those are wrong. Actually, does that even fit? Yeah, 803. Huh. Yeah, look here, I get 802, but here I get 001. I don't know why. Here's the same load. Left impend, but deadder's wrong. Isn't deadder literally just a wire to pend? Yeah, how does that not work? How is this wrong? That literally makes no sense. Pend is just a wire to deadder. Okay, what did I do? Pend is a wire to deadder. It's not even set. And that probably means one of the inputs is changing, but it like can't. We'll just put the same logic here. Oh, okay, now deadder is correct. Am I just not waiting long enough? Okay, now it works. Cool. Okay. We're gonna have to do a little bit more. We're gonna have to support all the weird sorts of loads. It's not actually just do load, it's gonna be like load type. And there's a bunch of different load types. So like if I switch over to LH, it's not going to work. actually just be do load. It should be load type func3. Well, I guess I can just search func3. Not great, but if do load begin else and syntax and assignment. What's the syntax there? What does the else syntax look like in Verilog? And else begin. And else begin. Gotta love it. Case. Shouldn't actually be func3, but it's the same basic idea. In case you don't actually need begins and stuff. Okay, so LB is this. And we want this to be data coupled with 24 zeros. Load word. That even looks more broken. Oh. Okay. Oh, this should be side extended. It's this syntax. Those are actually correct for these two, but for this, we want to say 16 B data, so 15. So we've got a sign extend. Sign extending in Verilog is phenomenal. So easy. What? Why doesn't it work? I worked hard on this code. LW works. LH does not. So I know what it's doing. Does LHU pass by chance? No, it fails in the same place. Oh, because look at the address. God, I gotta make fucking bytes work. Thank you. Gotta make bytes work. like non-aligned accesses, you know? Hmm. Hmm.
And now you understand why this is hard for chips. Well, Word works. He thinks it works in real life. I have to build that same struct here. We're writing it to an actual chip. Here, this is running the simulator. Wait, what? That was so fast. I almost can't believe it worked. Huh. No, I think something's wrong. Sure looks like it's working, though. Maybe it's working. I don't know what I did, but whatever I did made it use a lot less. Oh. Yeah, it was doing everything combinatorially before because I actually messed my pipeline up. But now that I fixed the pipeline, oh, it synthesizes with so much less resources. It's a long test. So when this is done, this is running the test right now, this will light up red if the test passes. These are lights from PC. No red yet. I don't know. Maybe always a pause edge clock div. faster? Like, it is definitely using resources. It does seem like it's just using less. Let's put sub-I back in. Can't find sub-I. Sub can find. I think it broke. Yeah. If the ROM is outside, it doesn't work. I didn't wire it up correctly. How hot's the FPGA getting? Not hot at all. It's running so slow. No, it's broken. Oh! How did that compile? I hate this. Well, now it's back to using resources. You make a typo, that's bullshit. How is that not caught by something? Oh, the Y-fuckers are back. Yay! Look, the red light turns on. That means test pass. Yeah. Oh, if you, okay. This is if it's doing the jump. Remember when we were just getting the red light there on the reset? If it's just the red light, it means it's not doing the initial jump. Oh, yes. Load word works. Oh. Dual port memory, 36 KBs. It's only 4.5 KBs. Oh. How much KBs do I have now? I think more. That many. What it was doing before was just running just knobs. So like it was running, but the memory wasn't loaded. And it should have given me a warning about that, but it didn't. All right, can we get stores to work? Right now stores don't work. How did that compile with that display statement still in there? This doesn't matter. Stores. You'll see why the load halves don't work. Because everything's denominated on bytes. Oh, I bought the board. Called VW data VWEN. I don't know if this works. Is that right? For store, I don't think it is penned actually. It's like VS2, right? Yeah, it's VS2. That might not have to be a register, actually. Oh, works. Now, can you synthesize that? Or is it gonna be like you have way too much RAMs?
No, it seems okay. All right. Slower now. Seems to work. I don't really get it though. Like, how does that work? Where is it putting all those registers? I assume it, like, the thing's not really stupid. It looks like it uses more stuff, but like, it's fine. Cool. I think that's pretty good. Got loads and stores working. Unaligned loads and stores don't work. If somebody would like to fix that, I will add a little note. Fix unaligned loads and stores for fast. Multiply and divide. And better introspection. Cool. Good night, everybody.